everybody. Space Audits and UBL. We'll be doing a night on Clubhouse with the gang tonight.
Trusted your word, believed in your quest. Now I see, though, just like all the rest. Trusted your word, believed your lore. Now I see through, can't trust you no more. Psychologically abused since I was a kid, believing your stories, the things that you did. Now I'm asking for my money back. I have it tallied up, 800,768 fiat dollars. Gave you my trust, followed your way. Now I see though deceit on display. NASA, you've been lying to me. Lies and deceit, it's all I see. NASA, you've been lying to me. But deception's a game you played every day. Lies and deceit, it's all I see. NASA, you've been lying to me with your fake streams and false reality. NASA, you've betrayed my trust with your fake streams. I stopped being blind, admit your unjust lies. Since I was a kid, you fed me lies, stories and fables. Now I realize, meant for the masses, to be force-fed to the blind. NASA, you've been lying to me with your fake streams and false reality. NASA, you've taken my trust through your lies and deceit, turned it to dust. You've taken my trust through your lies and deceit, turned it to dust. Trusted your word, believed your lore. Now I see through, can't trust you no more. Gave you my trust, followed your way. Now I see the you deceit on display. NASA, you've been taken from me. Lies and deceit, it's all I see. NASA, you've been taken from me. Believed in your quest. Now I see though, just like all the rest. Believed your lore. Now I see through, can't trust you no more. Lies and deceit, it's all I see.
NASA, you've been lying to me. Lies and deceit, it's all I see. NASA, you've been lying to me. But deception's a game you played every day. Lies and deceit, it's all I see. Trusted your word, believed in your quest. Now I see, though, just like all the rest. Trusted your word, believed your lore. Now I see through, can't trust you no more. Psychologically abused since I was a kid, believing your stories, the things that you did. Now I'm asking for my money back. I have it tallied up, 800,768 fiat dollars. Gave you my trust, followed your way. Now I see though you're deceit on display. NASA, you've been lying to me with your fake streams and false reality. NASA, you betrayed my trust with your fake streams. I stopped being blinded with your unjust lies. Since I was a kid, you fed me lies, stories and fables. Now I realize, meant for for the masses to be force-fed to the blind. NASA, you've been lying to me with your fake streams and false reality. NASA.
Maybe it's the app glitch that's been going on.
Yeah, that's what happened. I couldn't tell where I was.
Now through my Wi-Fi stuff.
That's what happened to me. I couldn't tell where I was. I couldn't find you guys. Although to be fair, I just follow your notifications and links to. I never actually had to find the group, the Flat Earth Gang. Like,
Oh, looks like Coffee is in the other room. I hope he joins us in this room.
that's right.
I like Coffee a lot.
Yeah, we've been pinging people in the room.
Does my mic sound okay? Sometimes on Club Deck it sounds good. Sometimes it sounds horrible.
No, you sound clear.
Let's go. It's a coin flip.
For now, Gally.
Yeah. Yeah, we don't know what the future holds.
Yes, we might as well get started. So peace to, Ether Cos and everybody stopping by. I believe this is supposed to be like a cell Theo. They calling it now. The celestial theodolite update. Some new observations and updates. So just let them make their presentation. Make it a conversation. We got some naysayers in the room, so should make.
Space House and Shane, if y'all off mute, we're not sure because we can't hear you. If you're off mute, we don't see your mic.
Oh, sorry. Are you guys
can't hear me?
We can hear you now. Yep, we good now.
There's both. Just Alan, not me.
All right. Yep.
Oh yeah,
Yep,
Shane, both. Yeah.
Okay.
Yeah,
Usually I got to
There we
rejoin a couple times. All right.
All right. So the celestial theodolite concept. We've been doing an update as often as we can for significant updates. So to start off with a basic recap of where we started off and where we're at now, we'll get into the process and methodology. So to start off with, the methodology is using terrestrial objects to occlude celestial objects. Now, by doing that, we can make some estimations and calculations that give mutually exclusive outcomes based upon the physicality of the location of an elevation of a mountain based on how far the observer is away from the mountain. So, on a flat Earth, the elevation of the mountain is going to be the physical elevation of it, and the angle that you perceive it at is going to be the thing that changes non-linearly, is what we would assert, but that's, we don't have to get into the complexity of curved visual space or anything for this, but needless to say, the elevation will be higher than what the globe would calculate, because the globe would calculate that the mountain is physically lower because it's tilted away, so there's going to be feet missing from it. Now, because we're using the intersection of the celestial with the terrestrial in these timings, we can see which timings better match the predicted models, right? So for a flat Earth, we predict that the occlusion timings will be earlier than what the globe predicts by, X amount of seconds relative to the conversion of arc minutes to real seconds, which we can get into in a second. But based on the differences in elevation, the time in which you see the star disappear will correspond to when it's at a specific angle. Now, an important thing to, are there any questions so far before we continue? Let me write
No,
this
all
down.
good.
Okay, so specific angle. Okay. So, now the specific angle, and for what we're referencing, is called the true geometric position of the star. This is what's called the almanac position of it, and that's. Oh yeah, you can come in. 1 second.
This is a dichotomy, right? It's mutually exclusive. It's either one or the other, A or B. No C, multiple choice nonsense, right?
All right, sorry about that. Where was I? Oh, it was the true geometric position of the star. So let's talk about what that is real quick, because it's extremely important to the modern astronomy tools, especially Stellarium. So the true geometric position of the star is the position of the star on the first cusp of Aries, which is the vernal equinox. So wherever that star is, the zenith position of that star, which directly corresponds to a ground with that directly corresponds to a position on the ground. So with that relationship there, they and based off of timing 15 degrees per hour, they predict out where that would be as the physical location of the star, not the apparent position of the star that we actually see, right? So these are two different concepts. There's the true geometric position, and there's the apparent position. The apparent position is what you see, right? So when we reference Stellarium with refraction off, it's referencing the quote unquote true geometric position, which is a position which, if there is a physical object that existed that represented where that star was at a specific time, that you could see it with perfect ideal optical conditions, getting that zenith measurement on that specific night, and then calculating 15 degrees per hour where it would be moving at that rate. This is where that physical object would be. And then of course there's the refraction corrections that are elevation angle dependent, that will move the star to where it needs to be to use the latitude longitude coordinate system. But that is what it's referencing. So there's two separate references, apparent and the true geometric. Now our position, and this is extremely important, is that we're referencing that so-called that true geometric point, and when that uh, when that when the true geometric position of that star lines up with the angle that we calculated that's relative to our distance away from the mountain, we're going to use that same angle. And if at the time that the star is at that angle, because we know we can use Stellarium to know when the star will be at that angle at the time, and if we're recording on the ground from our location and we see that star, and then at that time that it's at that angle we suddenly don't see that star anymore within 1 second, then that's a good indication that it's been blocked by a physical object, because a refracted object will not block starlight. So I think I put it on my YouTube, but if not, I'll upload it later. But we had Taylor put a knife in a cup of water and, moving the source of light to the refracted image, the light shines through it. And then when it actually is occluded by the physical knife, that's when it's not present anymore. So using this method, we're able to ignore the terrestrial and or celestial refraction between us and the mountain peak, right? Because if it's refracted, we're looking at it through the same optical corridor. So as soon as we don't see the star, the refraction angle is 0. So refraction in that regard is not applicable. And keep in mind, this is the huge distinction here, is that we are not measuring a physical angle. This is a calculation based off of timing intervals. Corresponds to an angle, but we are not optically measuring the angle. If you were to measure the angle optically to the mountain, it would produce what the quote unquote globe predicts. Now we assert this is an optical phenomenon due to nonlinear optical compression, whereas the globe asserts that this is due to 8 inches per mile squared, approximation of the ellipsoid model. Any questions so far?
Well, can I just maybe? I think
Oh
maybe
God.
you would agree with this. I just wonder if this is a simpler way of saying some of what you said, which is that we can use Stellarium if we know what time it is and where we want to get the information from. Stellarium will tell us for a given star at a given time both the geometric direction to that star and the visual direction to that star. Is that fair enough?
Yep. Yep.
Yeah.
And so I had a question also about the methodology when you mentioned like the concept of the geometric position as opposed to like the apparent position. In the geometric position, is there any consideration in the way that it was laid out, that is laid out for actual distance, like a radius or anything like that, or is it just purely just angles from like a zenith?
So that's a fantastic question. So there is a
Man,
distance that they do assert for that. So to make everything set to an equidistant web and to align the terrestrial sphere and the celestial sphere, they align it at the center, at the center of Earth, so called. So they actually place a fictitious observer at the radius, at the center of that radius, and then outwardly from there would be 3959, and that's where your star would be at the zenith. So so they're like, if you want to triangulate distances to stars, like making different assumptions, you can, obviously different baselines, you can have you'll produce different distances. But for the purposes of using for using celestial navigation, on the ground to find out where you're at or where you're going, you have to use this 3959 value.
All right, cool. So what's the 6218 number? What's that one?
The 6218 is the linearized version of that. So if you take the latitude lines and multiply them by 60, or 69 for statute miles, you get 6210 or 6218. So in other words, if you take a longitude line and stretch it out, and which would just be the equivalent of walking from the North Pole to the equator. When you get to the equator, you're gonna see the north. You're gonna see the North Pole at 0 degrees or whatever, and that, if you were to multiply that out, and that's the value you would get on the ground.
Oh man, here's another app here. Cool, thank.
Yes, sir. So yeah, a really interesting thing that I learned from all this is the usefulness of the fictitious observer to tie all these zenith measurements together, because they all have to be relative to some fixed point. So they've got all these stars lined up where they take their zenith measurements on the first cusp of Aries, and then everything calculated outwardly from that is based on 15 degrees per hour with respect to the Greenwich Observatory, to set your default line or your zero line or whatever. But yeah, it's that's what ties it all together, is that radius value. So some say that flat earthers made up the azimuthal grid of vision, and that's all BS. But if you want to do cell nav, if you want to actually get down on your, use your hands to do some cell nav or whatever, you're gonna have to do a geocentric coordinate comparison to the first point of Aries of that star you're using, and that's gonna, you're using a fictitious observer at that point.
So they're at the center of a celestial sphere that's kind of distributed out equidistant from them, from their position. Right?
So check this out. They say that the celestial sphere, and the way that they conceptualize it, is a sphere of infinite radius. So you can think of that as if just like you can conceptualize that as going out to infinity, being coplanar with the Earth, irrespective of how big we may think the Earth is or whatever, right? But just there's the celestial sphere. It has an infinite radius, right? Now they have the terrestrial sphere, and they're trying to relate positions of stars and how we see them to a single location. So they bind it to that 3959 there. So they instead of like saying that the way that we see is curved, they just like basically underlay another spherical model that's symmetrical, right? And then tie it to that same center point. So even though the celestial sphere has an infinite radius, when you combine it with the terrestrial sphere, you can now relate positions of the stars and angles to latitude and longitude. Sorry, I'm not sure if my mic's cutting in or out because that volume
Nah,
activation
he
thing
coming
is
through clear.
flickering. Am I coming in good?
Yeah, he coming through clear.
Cool, cool. All right, cool. Yeah, and it's like so if you have the freedom to move an observer to a fictitious location, then you know what's really cool about the Walter Bislin model that's or the Shane ADL approved Ether Cosmology approved model is like if we're using fictitious observers to unify our coordinate systems based off of single zenith measurements, that doesn't really tell us anything unique about where we live. Uh, you know, because you're just tying it together with a fictitious observer. So that's why they can use spherical trig for everything because they're the way that it's bound into a spherical coordinate system. It doesn't have to relate to the ground at all.
I wish I had a little more insight into like how, what tools business or what data has he used to be able to have that relationship between the actual position, like the geometric position, like where you see the actual little sun, and then the one, like I guess the apparent position for a person, for the person in their own little sphere, like the smaller sphere on the inside. So say from each position, what snapshot of what moment are they like? What position of the position of the sun at what time? Is it at what time? Like, are they syncing it up to one specific time for each observer or something? Like in order to make their coordinate system.
For a single observer, yes. Like that's how it's always been derived, like single zenith measurements. So like when you look at the conceptual model, right, you might get the mistaken impression that that's like a God's eye view of what it would look like or whatever, but we've only ever seen what's inside the little tiny as a mythal dome, right? So like beyond that, beyond how we perceive it, in that curve, that's all that's ever been referenced. That's all that's ever been available. So like when they show the 3D globe, I can actually maybe show some slides here. I think I can get Kat to post them on for me.
Post slides.
Yeah, I'm gonna post a link for you.
And send me the link and I can post it. Yes,
okay.
I can post the link.
All right, I will work on that in a couple of minutes here. Shane, if you want to take over for a minute. So we're go ahead.
Just wonder where he got the insight to do that. The last few times, definitely the first time that Heffron came through and gave Dr. Heffron came and gave the presentation the first time.
Can I offer another take on the astronomical refraction thing? It's yeah, I think it would help people to understand where it comes from ultimately and how it's known, how Stellarium knows it is because stars in general, when they're high in the sky, all stars rotate, as one, right? The celestial sphere, I think we all agree on that. The celestial sphere appears to rotate as a solid object, except for minor motions of the sun, the moon, the planets, etc. The stars, at least, all kind of rotate on a nightly basis as if they were fixed in the sky, and they rotate at a constant rate except for when it starts getting toward the horizon. They slow down a little bit. They don't move at the same rate that they did when they were high in the sky. And that's understood to be a natural result of the fact that astronomical refraction lifts stars more and more as they approach the horizon. So by looking at, in detail at how those stars deviate from the absolutely standard constant speed that they usually rotate at, you can determine the astronomical refraction. And that's what Stellarium uses to correct values, especially near the horizon.
That's
What Okay, well, the key thing is that the amateur astronomers depend on Stellarium to tell them how high to point their telescope above the horizon and at what azimuth, what bearing clockwise from north. And that's what Stellarium does, tells you where to point your telescope. And to do that, it uses that formula.
well, the real takeaway though is that the use of the empirically derived formulas based off of model assumptions, multiple model assumptions to, facilitate making the stars, or like explaining how the stars coplanar as it uh, goes out of our optical limit, doesn't really, you it ruins mutual exclusivity for number one, right? Because it's not derived off of first principles. But so like that's the actual important part, right? It's not that no one's disagreeing that the corrections don't put the star where they need to be to use the latitude longitude system. Like we're saying that the globe is made up in the refraction and celestial refraction correction differences. Now, to move on with the analysis, let's see here. I forget. I think it was Celestial Theodolite update 5, maybe, or so. There was an anomalous reading with Green Mountain, and there was I think there was another one that had some weird thing, and that went unresolved for a while. And Mike came up with a new way to do an analysis or whatever. He found a mistake in Stellarium, he said, where the bearing or whatever was off by a day. So by doing some method that I'm not super familiar with, like if you asked me to steal mana right now, I couldn't do it. I need to better understand what he's doing to determine his corrections or whatever. But when he's applied those, they say, it comes out, it like resolves the anomalies or whatever. But I don't know too much about how all that works. And in addition to that, Jesse has put out some measurements using his simulator that show that give the globe result. Now, the thing that he was using, or like the way that he did it, was being at sea level, and then if the celestial refraction correction angle is the same as the elevation of the mountain or whatever, like it gives the globe results. So that's, I mean, it is a way to produce the measurement you like when you cook it or whatever. And we have people. Well, I have one guy who has done his own measurements, and those came out flat, but those aren't released because it would dox him. So he's not like, I don't argue those or. But what we did do is we purchased our own C star, and we're going to add to the data set and go from there. Because the guy that did his measurements used the regular analysis, no changes or anything, and everything matched out fine. So not sure what was going on with the anomalous stuff, but there are some anomalies. But we are pressing forward, and we're going to add to the data set and see what we can come up with. And we
Well,
have
as
Nice.
Jesse
All right, so
mentioned,
weekly
all right, go
meetings.
ahead.
go ahead.
Yeah.
Well, I was just going to say, I heard Jesse mention the other night, it's certainly true. I mean, thousands, tens of thousands of astronomers around the world depend on Stellarium to tell them where to point their telescope. And if there is any error in there, it will be known and fixed. So Mike's finding errors in Stellarium is a little, I think we have to take that with a grain of salt.
Way to say the
Man,
same
I'm
thing
glad you
again.
actually said that because that was kind of the question I was going to ask. But whether it's Stellarium, I don't know, maybe somebody could either clarify if there's a difference between the data you'll find in up to date like an almanac and Stellarium. Is it the same data?
So, so
And
from my
which? All right, so go ahead, take a go first.
Yeah, so from the best of my understanding is that there's two different sources that he was using, or well, he was using one source to for his bearing when he was doing his calculation to like align that for the position of the star. And he was saying that using a different source to get the bearing, it corrected it for that day. So he said that the bearing that Stellarium had listed for that day must have been off. And keep in mind, we're talking about a really small correction. It's not like it's not off by like multiple degrees or something like that. This is like a real tiny thing. And this has only happened a couple of times, I think. So I don't know. Like if we start running into the same issue and it's like a bearing issue, then it'll be sorted out in the future. But like, as we know right now, like that's the best I can offer in terms of an explanation right now. I have to get with him and learn more about the exact process of it and do it myself. Honestly, it's the best way to do it and learn it is to do all the steps yourself, and I have not done them yet.
Right, no, all good. Thanks. On the other part, I guess both sides have an argument, like a claim, I guess, to the celestial sphere and the which is, I guess, what the celestial theodolite is here to to sort out. But I don't know, John. Maybe we could let John go first, and then you guys can make your case as to um, the data in Stellarium. Is it exclusive to a globe, or is it something that, as far as like the methodology that went into getting the data points that make up the model, is it something that is exclusive to a globe in any way, or is it something a flat Earth can lay claim to as well?
Well, I can answer that if you want. Should I go? I mean,
Yeah, go ahead.
Stellarium, yeah, Stellarium, all of its calculations are based on a full sphere of stars, right? I mean, you can't fit the stars in the sky into anything less than a full sphere, not a hemisphere. It's based on the fact that at any given time, half of those stars are on the other side of the Earth from you. It knows where. You can ask Stellarium the geometric direction to any star that there is, and half of the time it will tell you that it's down there between your legs, right on the other side of the Earth. And it has to do that right. It uses the fact that the celestial sphere is a sphere, and then it uses your location and the time to know how that sphere is oriented, and therefore what direction you'll have to point your telescope given where you are to see that star. And it does that. It has to do that right. If it doesn't do that right, nobody will use it.
Is that it? All right. So we
Yeah.
only see in half of a sphere, right? So if the stars are circling above us, we're only going to see in a hemisphere at a time. That's not an issue if they circle above us. When stars are mapped to a negative coordinate, that means that they're no longer visible. If they're mapped to a spherical coordinate system, if you want to say that they're beneath your feet and model that out, that's fantastic. But that's also equivalent to just being out of your field of vision and cycling above you. So an easy way to map that out would just be using negative coordinate systems. So that's there's no mutual exclusive claim there. That's just math graphing and stuff. And then on top of that, so like in other words, that doesn't assert a dynamic cause. It just says it's no longer visible. Why it's no longer visible is what's in contention, right? So that's why using the celestial and terrestrial intersections of said stars with respect to their true geometric position is where we can start to draw distinctions. Whereas you have to use secondary back-ended corrections and assertions to reify your position. And the use of a fictitious observer really renders both scenarios in terms of what it basically solidifies it both as conceptual models. So the globe is a conceptual model, and the way that the AE map is projected for the Bislin/Shane model, those are conceptual models for how an observer will see the sun and stars with respect to them, like for just them, right? Because in our assertion, is that the sun and stars and all that are non-physical, so we don't see like, in other words, the way that they would triangulate out to a physical point and call that real and then all that stuff, that's not like, we don't put
Yeah,
any
that's what we
stock.
disagree with, essentially.
We don't put any stock into that. What you see is apparent and localized to you, and a good demonstration of that is when you're standing at a lake and you're looking at, or you're standing at the ocean and the sun is low on the horizon and it casts a ray individual to you that goes to your feet. And then someone standing next to you has their own individual ray going to their feet. If the sun were a physical object illuminating the water like that, you would it would be a giant beam that everybody would see collectively together. You wouldn't have your own individualized beam. So our interpretation, and not only that, there's other instances too. So like if you like the corpuscular rays that you see, for example, if someone at 180 degrees away from you is going to see, or opposite to you is going to see, completely different corpuscular rays coming through a cloud. So what you see in the sky in regards to celestial bodies is unique to you, and latitude dependent observations of them, we don't have like a God's eye view. That's why I was like stressing the importance earlier of the conceptual model. No one has that God's eye view. We only have that single hemisphere observer at a specific time, and then everything stitched together with a fictitious observer to merge a terrestrial sphere into to merge a celestial sphere into a terrestrial one, which is just a set of coordinates based off of two hemispheres, just based off of positions of the stars at one hemisphere at a time.
Yeah, and primarily what we say is that it uses the almanac, which is true. It also uses an ephemeris, which is the geocentric ephemeris. Even the JPL is geocentric, and then it relies on catalogs for the navigation style data. So like where it gets its data is the observation from history. Everyone knows where and when a star will be. And of course, in both models, we only observe a hemisphere. It's the globe that constructs all observations into the celestial sphere, right? That's fine. It doesn't mean that it's wrong. It's just the conceptual model that, takes the empirical observations and puts them without any dynamic implication into a model. So, are we doing the celestial theodolite, or are we just going to debate John? I mean, I'm good either way.
No. Well, it was part of that, I guess, because it was in relation to, because like a big point of contention is, are we allowed to use Stellarium? Is it a mutually exclusive globe tool? So it's important to go over the aspect of, like, you know, the importance of what is a conceptual model. Like are we allowed to use it? Like, is it mutually exclusive? Does it mean globe? Because every time we pull it up, you know
Well,
what they say? They're like, oh, look, they're using the globe. Like, so it's
well,
like, okay, well, let's get down to what this is. What ties together this globe you speak of, right? Is it based off of curve fitting observations to fit an assumptive model that's based off of spherical coordinates, or does it have anything to do with the ground, right? And how can we tell the difference?
no,
Well, just based off of
So,
observation alone, nothing really can be determined. That's why
so
you
I
have
would,
to do section
yeah,
dependent.
I think it's. I sorry. I think it's. I mean, I don't want to. I don't want to actually worry about what Stellarium is based on. I mean, I know what it's based on, but it doesn't matter. The only important thing is that it gets the answers right. It tells you. In fact, I mean, what it does is it determines the geometric direction to the star. That's what it does, because that's easy. That's easy in the model that it uses. And then the complicated part is adjusting that geometric position for the effects of refraction to determine where the person with the telescope who wants to know where to point the telescope needs to point it to see it. That's really it. And as far as tonight goes, I actually don't particularly care to debate the data or anything. Jesse takes that approach with you guys. I really just have kind of two questions on the method. And anytime you want, I could just ask those, and I could be done with it.
sounds like an at the end
Give me
question.
one sec. Go ahead and ask.
Well, so number one, let me put this a link in the chat so that we can all kind of be on the same page. Take a look at the thing that I just posted in the chat, which is really just kind of a question about, why, because I love the, I mean, as you know, Alan, I've said many times, I love the idea. I think this is a great idea
You said you had a question,
using,
John?
yeah. So the question is this: why isn't this the way to do the celestial theodolite, as it shows on that diagram? You wait for a known star to appear visually at the same position as a known peak, just like it shows in the picture there. And at the time that that star is at the same position as the peak, it's about to be occluded. It will be occluded in the next second or whatever. That's when you want to jot down the time. You jot down the time that that happens. And then you simply ask Stellarium, what was the visual elevation angle of the star? That's it. And then you just compare that elevation angle to the angle that you calculate with your favorite model of the globe, with and without globe drop, basically, if you want to compare flat Earth to, to globe Earth. And if you do that, for instance, with the Pikes Peak observation, where you get a globe Earth elevation angle prediction of something like 2 degrees 18 or 2 degrees 19 minutes, and you get a flat Earth elevation angle prediction of something like 2 degrees 31, 2 degrees 33 minutes, depending on whether you include terrestrial refraction. And you don't really have to, it doesn't make much difference. There's a big difference in the calculated altitudes of those things. And if you put in the time at which Mike Heffron saw 39 Aquarii occluded, it says that it was 2 degrees 18.8 minutes above the horizon, in almost perfect agreement with the globe. And I just don't understand why this is so simple and obvious. I don't understand why you don't just do it that way.
Because that's retarded and not mutually exclusive and not the method.
So that's my question.
It's the
Why
answer.
don't you do it that way? I think I know the answer, but go ahead. I'm
How do
not
I
hearing
see?
anything.
How do I see your
Okay.
image?
I put it in the chat. It's three comments up in the chat right now. Maybe Liz could put it at the top of the page. Elise, sorry. Somebody could put it up at the top of the page.
Beast, can you send me
But
Can you send it to me on Discord? I don't have the chat open.
Oh,
I only have the voice chat, and then
well,
I can join the same room over and over again. Give me 1 second.
okay. Well, let me see if I can do that. Sorry.
Well, what he said was you look at a star and base what refraction will show
Actually, if
you
I'm gonna,
and where it will be.
yeah,
Can
can
you
you
guys
do
hear
that,
me?
Shane?
Yeah, I
That'd be
sent it.
great.
You're good.
Okay.
Can you guys hear me? Did I change mics? Oh, fuck.
Had me nodding off, John. Just
Good. I'm
kidding.
I
glad I
kind of
can.
missed the just the
Better than
thrust of
no
his
dose,
question.
huh? Oh, and a no. What am I saying? No dose. Melatonin.
Yeah, okay, I see what you're saying. So the big distinction here, right, is that you have to tell Stellarium where you're at. So you're not making any sort of prediction, right? What the big difference here is that we don't require knowing the viewer's location to determine.
Whoa, everything broke? Sound broke. Hold on a second. What happened there? I mean, no, disable this. Crappy. Okay. Let me rejoin the Clubhouse thing.
That
There
star
we
with
go.
that peak, well, the globe predicts it's in a completely different spot than the observer who's making the
Oh,
measurement, and
I don't understand that.
the two angles align. It shows that the angle isn't relative; it's an intrinsic angle. It's physically real for that observer. That's the
So
significant
in
implication of it.
in your method, as I understand it, you do need to know the observer's location in order to calculate what the flat Earth prediction for the elevation angle of the peak is, the thing that you're ultimately comparing to another angle.
Nope. Comparing times. You're lost in the sauce, John.
So you're saying you don't need to, it doesn't matter where
We don't
Heffron
need to
observed
consult
that from?
Stellarium. No, we don't need to consult Stellarium. All we enter into Stellarium is an angle that we derived based off of how far we are from the mountain peak.
Right,
That's
where
it.
the observer
Hold on.
is.
Where's the star observed from?
From Mike's house or
That
wherever the
E-
observer is at.
could be,
Right, and
Exactly.
you have to know that.
well, no, it
So
could
the
be
star
anyone who sees the mountain. Anyone.
so the star that you see with your own eyes, right, from Mike's house, right? That
Anywhere.
star has an angular relationship to its horizon, correct?
Yep, and it just so happens to intersect with the physical mountain peak at that same angle. Isn't that
Perfect. So why
crazy?
wouldn't the distance between where that star is visually observed and Mike's house matter?
Because the globe makes two different geometric predictions. And we're showing that this isn't the case, that the true geometric position corresponds to planar geometry. That's the significance of this.
So do you is your claim that that occlusion would have happened at that time regardless of where the observation was made from?
For anyone that can see the mountain. That's the
Anyone who can
implication.
see the mountain.
Because
Oh,
Stellarium
really?
doesn't
I
know
mean,
where you
seriously,
are.
that's okay. That is news to me. So your claim is that anyone who can see that mountain will see it occlude that star at exactly the same time.
So long as they're the
Because
same
if
distance,
that's the
yeah.
case, I have to go off and make some more diagrams. I think everybody can see that that's nonsense, but that's not really, you don't really think that, do you?
Same distance in the circle all around the right. So any observer on that circle around that mountain can make the observation. The whole point is it's the
Right. What
same for
circle?
everyone because the only location
Right.
you put in is the mountain. So therefore, the important part is the mountain, which is why the
No,
timing
it's
is based on the angle from the mountain, which is why it's mutually exclusive.
so where did you get the radius of that circle that you were just referring to?
You can
Isn't that the distance
50.7
from the
kilometers
mountain to
from his
Mike
house. Yeah,
Heffron's place?
sure.
Isn't that the distance to the place where the observation was made? And don't you have to know where that observation was made to know that?
Just how far away it was, John.
Right, exactly. How far you have to know how
That's our
far
premise,
away
man.
we have to know the observation
He
location.
triumphantly
Now,
concluded our premise.
now hold on a sec. You're claiming that anybody that distance away from that mountain will see that star occluded
And the
by that
bearing.
mountain
You gotta have the
at
Hmm.
same
that
bearing.
time.
Yep.
Same bearing, same distance. What location is that? That's Mike Heffron's house.
And why is
Which
there a
is
geometric relationship with a mountain peak that's too high, occluding a star with respect to its true geometric position when it's supposed to be at a different spot?
Okay, so
That
let's
is the
back
that is
up.
the question.
We've
Like
now
like we're
we've
going in
now
hella circles now, John.
that's the
so
whole point. It's this thing.
we've now we've come back. That's fine.
Now
So
we're
we
gonna
now
speak
know
really
that we do
slowly.
have to know. We now know that we do have to know exactly where the observation was made because that's the only place that the occlusion happens. So now the question is, since you have to use that, why isn't the obvious thing to simply wait for the occlusion and ask Stellarium what was the elevation,
Yo,
the
John,
visual elevation
John,
angle up? Can I just
we
finish?
can backwards
What?
derive the
Why
distance based
not?
off of the angle,
Can
based
I
off of the
finish?
timing,
Okay.
bro. No, you can't. This is ridiculous. We can backwards derive the distance off of the time in the angle. So we don't need to put in the distance. That is the significant factor. We never told Stellarium where we were at. I'm not going to listen to you do the same line of argumentation over and over. This is so fucking monotonous, dude. This
It's
is
just
our
Your
that's
filibuster.
our
It's just
premise.
filibuster, brother.
Yeah.
We
You
can
just
ultimately
backwards
your
derive it.
comparison.
We do not need to tell Stellarium. We've established we have to tell. No, we absolutely didn't. We can backwards derive the distance from the angle and the time.
So ultimately, though, you're comparing
Predict where the
the
observer
angle.
was, dude. We can predict where the
Ultimately,
observer was. You have to be told where the observer is. Good game,
okay.
sir.
So ultimately, you're saying that the occlusion happens when the geometric direction to the star from the peak is equal to the geometric direction to the peak from the place that the observation was made, right?
no, you're just trying to speak really slowly and eviscerate emotional responses as an argument, and it's really gay.
Is that wrong? Is what I just said wrong? That's, as I understand it, the celestial theodolite method. When the angle, when the geometric direction to the star from the peak is the same as the geometric direction from the observer to the peak, that's when the occlusion happens because you've defeated refraction. Am I wrong about that?
I wasn't listening. I thought you did. You
Uh,
just say the same thing
okay,
again,
so
or
well, I think I've made my point. Maybe I just move on to my second question and then I'll just finish up.
holy shit? That wasn't. That
So
was only
this,
one question.
Dude, that was the first question. Jesus Christ, dude. What's the next one?
here's the second question, and we're almost done. Shane, maybe you or somebody can send this link to Alan as well.
I'm sure it's riveting. Let me see. Oh,
Okay,
look,
it's
you're
done.
refracting a
This is
shadow again. This is cool.
so. This is the part I. It seems to me that you spend a lot of time talking about the geometric direction to the star from Pike's Peak. And that's just the extended line of your celestial theodolite that has its crosshairs on the peak and its lens down there at Heffron's place. So it's just a nice straight line from Heffron's place to the peak to the star. But the problem is that Stellarium will tell you if you just ask what is the geometric direction to the star from Heffron's place, it'll tell you it's nearly a half a degree lower. It'll tell you that if you wanted to point your telescope at a defeated refraction version of the star, that star is at 2 degrees and 5 minutes 5.6 minutes or something, way below the peak. So the question is, how is it possible that the geometric direction to the star from Heffron's place isn't the same as the geometric direction to the star from Pike's Peak? You're just looking right at the star. There's no refraction. Why isn't the geometric direction to the star from Heffron's place 2.548 degrees?
Are you confusing azimuth and elevation angles? Because you're talking direction
Nope.
over and over again, and that's azimuth, right? So,
These are elevation
right.
angles.
Okay, but what you have here is two different measurements, 2.548 and 2.093, neither of which is the correct
Those aren't
unrefracted.
measurements. That's what's
What is
not
that?
measurements. It's what stellarium, the thing you're depending on, tells you is the geometric direction to the star from
Right,
Heffron's
right. So you're
place.
using an optical argument again with refraction on both
Nope.
ends. That's why we have the
Nope.
occlusion timing, the timing of the occlusion being the predictor of the angle. Like that's how we do it, right? That all this other stuff about moving the observer, putting in your location where we don't have to, and trying to make it from two ends is an obfuscation from the mutually exclusive point, right? So because you don't have a timing and you can never have a timing, these are the tactics you have to do. You have to viciously put refraction at both ends, try to incorporate it somehow, make it about optics, make it about where you see it, and make it about the other observer where the observation is not. The
There's a lot of
celestial
straw man in there.
the celestial theodolite concept, John, is that my theodolite is 50.7 kilometers long. It doesn't end until
What?
the crosshair occludes the star. So that big motherfucker is the same distance from everyone. That's why we don't need to put in
So
where the observer is. And there's no way that you can eke out of that when invoking a refraction, celestial, terrestrial, or otherwise.
And
okay, there's
John,
a
you
lot of
know, if
straw
we
men
go
there.
back and we pull up the original room really quickly with when Heffron
Yeah.
came, you conceded to as much, right? You thrilled about it, right? You were like, oh,
I am.
that's
I
right.
love the
You can.
celestial
It's
theodicy.
almost like you can extend the theodolite. You agreed with the concept that it was like a go gadget theodolite that you could pretty much put right,
Yep, that's good.
right
No,
at the
that's not what I
the
agreed
peak of the
with. But
mountain.
what
Well,
I
I
like is
kind of
the
made that part up.
idea. Sorry, what I like is the idea of using stars to determine the elevations of peak. And the obvious way to do it is to wait until a star is visually at the same place as the peak
You're
and
gonna say your
ask
same thing
Stellarium,
again and
how
then
high
again
is
and
that?
again.
I actually, well, it's just so simple. I don't know why I should have to say it
Well, you asked
again and
both your
again.
questions. I think we gave you an answer. Does anyone else have any questions?
John, thank you for the
Okay.
questions. I think it's a
Yeah,
strange
all
line of
right.
reasoning, even for you, sir. Um, yeah, just I think it's a real strange where you're going with this one, John.
No, the way he's going is actually on point, right? Because that's what anyone would do just looking at the diagram. That's what I did looking at the diagram without the refraction, and I got the glow prediction to half a minute, I
Ooh,
believe.
that's a post diction, my man. Did you say you had to know where the observer was first? Sorry,
Ooh, and
that's called a post. That's
then
called a
apply
post
some
diction.
coefficients and a
Sorry.
celestial correction. Oops.
Yeah, unfortunately, that's ad hoc.
Yeah, but are we not viewing the star from Mike's house? Is that not where the observation takes place?
Is the observation not being occluded by an object that has a geometric relationship calculated mutually exclusive to planar geometry? Is that
That's
what's
that's not
guiding the
that's
star?
that's that's not what
Does
I
that
asked you,
timing
bro.
correspond?
The observation takes place at Mike's house. There's a distance between Mike's house and the mountain peak.
Well, how long is my theodolite though?
Very long, many kilometers, probably
Coffee.
over 49.
Dude, remember,
It's 50.7
all the
kilometers, right?
Okay,
enthusiasm
right.
for the for how it
Right,
works
but
until you have to
it's
actually have
still
the measurement, it
observed
doesn't
from
make sense.
Mike's house.
How can that be? I'm not observing out the back end of my stand. I'm observing with my crosshair, which is at the mountain. That's why the whole argument is put forth to eliminate this
Where's the
unfalsifiability of
theodolite, Shane?
refraction. The,
Where's the theodolite, Shane?
the theodolite's at the mountain, man. That's where it ends. That's where it terminates. That's where the
He put the
occlusion.
theodolite at the mountain?
Can I
Coffee, do you
put it?
disagree that the mountain is the crosshair of the theodolite? Are you contesting
I
that?
agree to that already. Where's the observer?
It's the
If the
dude.
crosshair is at the tip of the mountain, the crosshair is the tip of the mountain. Why would you think the observer is anywhere else?
Right. And then why would why would the person, the other half of my theodolite at the other house have any bearing whatsoever on any refraction,
So
right?
it matters. It matters at what the angle of that theodolite is. It's not the crosshairs of a theodolite do not determine what's in the crosshairs. It's the angle
We're
of
not
the theodolite, and
we're not
that
calculating
angle,
Oh,
that.
you
so it's a
see, Kemp,
category
that
error.
angle
You
is,
guys think that that
God, I can
matters.
never finish here, I bet.
You can,
Can I
but we're
finish?
sick of you, John. If that's
So,
cool.
All right.
Yeah, it's
All right.
just
yeah,
because
no, I
John, the
know
way
you
that you
are.
talk is really slow and it's
Yeah, okay, I
really
know you don't
annoying the
like the way
way
I
that you
talk, you don't like the
stultify
things I
the
say.
conversation.
Yo, I
You
don't know
see
how you guys do
how
this.
annoying that is?
Like, you guys
John,
are
do you see how annoying that
legends.
is?
You see all the time. You guys brought us onto this. You guys handled him for 2 years straight. Hats off, man. You guys are jeez.
Yeah, I don't know how you guys dealt with John for so long. He's
Man, and
insufferable.
he
This is
launched a personal
stultification
crusade
begins
against
here,
me, man.
baby.
He had whole YouTube videos like warning people
Yeah,
about me, warning the government about me, like I was a threat to democracy.
dude, you're
I,
a you're a
hear how y'all feel about
vicious
John,
threat.
fellas,
Fucking
but
crazy.
stop dancing around the point. Let's get to the point, my guys. Just answer the question, y'all.
Yeah.
We did.
Well, I asked you a question. Why would
We
you
did
think the
multiple
observer
times,
is
man.
anywhere
Like, if
else?
you disagree with it, then like that's, to quote my boy, the Big Lebowski. That's just like your opinion, man. Like, if you either get it or you don't, it's all good.
Like so, the way I see it, it's almost like if we can make the same, like let's claim after they fix everything, they get the position, they get the extra, if I can get the same bullseye, get the same output with less input, and I don't need any fine tuning before or after on the front end or the back end, then I think I have by definition a more efficient thing. And if you need extra data, you need to know the exact position to tune, tune it on the front and then tune it on the back, then that's it's bullshit. It's just not as efficient a thing. It's like I got a gun, I can just point and shoot, and you've got to like dial in a bunch of knobs, and then you got to like remote control it after the bullet comes out. I'm just to me, it just feels like I just don't see how you don't see that this is a better, a more efficient, more, cellular thing.
The whole point of it, though,
I
was to exclude refraction because with refraction, it's unfalsifiable. So the method was created to exclude that premise by extending the theodolite to the mountain and thus concluding only the flat Earth prediction is right on all of the observations. So that's why everything you hear about the globers will give you nothing about how their timing is wrong forever and everything about where they think the star should be at and using refraction. Sorry.
That's key. What you just said is key. It's
Also,
they never want to talk about their own timings because guess what? They don't have them.
yo, and check this out real quick. Just to reiterate the fictitious observer. So remember how it was like, where's the observer? Is it the mountain? Is it at his house? Who knows, right? But remember, the entire conceptual model, the ability to use Stellarium is all dependent on tying it to a fictitious observer at the center of a terrestrial sphere model so that it overlays with a celestial sphere model. So like suddenly a fictitious observer, if there was one, is a problem, right? But when they needed to reify their belief, it's all good.
See, what you guys are missing, right? The crosshairs, right, is at the mountain peak, right? But the occlusion is observed from the observer's position, which has a relation to the horizon. So obfuscating that, right, it's just finessing the numbers into your favor. You're just reworking math.
No, coffee. The globe makes two different predictions, and then on top of that, right, these are different timings.
No, it
So,
doesn't. I'm sorry,
that
Alan.
both,
This globe
yeah.
makes no predictions in the
That's
method.
true. You can say that again.
You simply see what the elevation of the star was, and you compare it to the elevation of the peak, calculated however you'd like to compare
Oh,
it.
did you say tell
But
the
you get the
Stellarium
elevation
where
of
it's
the
at? Yeah,
peak
we heard you, John.
from the elevation of the star. Nothing could be simpler.
But what you said was true. You can't predict it. You can only correct it based on the observer's location, right? Which is how the whole globe
No,
is built.
I
Absolutely
can
true.
predict it
Anyway,
too, but I don't have to.
And keep in
I
mind,
simply use the star to tell me what the elevation of the peak is. Period. Done and done.
irrelevant and unrelated. Anyway,
only by first telling Stellarium where you're at. That's true cowardice. Anyway, what are you guys
That's
up to?
right. And you have to know where the observer was too,
nope.
because the occlusion
No,
doesn't
no, I literally,
happen
no. I'll
anywhere
explain this
else
again because
at
I'll
that
explain this again.
time.
We only need to know what peak occluded the star at what time.
No, you
That's
have
it.
to know what
Yeah, we can
time
know,
it occluded the
buddy.
We just
star.
said that.
That's my
Stop it.
fucking premise, bro. I just said that.
And he gets you every
You
time.
can
It's the
backwards
point.
derive the
And that
distance.
only happens from the observation point. It doesn't happen anywhere else at that time.
Math says otherwise. John, if your whole
For
point
anyone at that distance along that arc, it does. So I don't know, man.
No, it
I just
doesn't.
fucking work here. Well,
I
that is the
mean,
geometric
There's no
relationship.
place on
That
the
is the
ground
significance of it.
near Heffron where that occlusion happened at Pikes Peak at that star at that time. That's the only place it happened.
I guess the question is, John, do you think that the refracted mountain could block the actual like the star that you see, like
No,
the actual position of the
it's the
star? Or what
physical
about vice
mountain.
versa?
It's the physical mountain blocking the star, and both the star and the peak are refracted by the same amount on the way from the peak to the eye of the observer.
Okay, so I haven't just to the guys who really are familiar with the data set that's come in so far. Does the globe get closest to the correct timing when they
It,
correct
it,
for hold on, bro, when they correct for
yeah, sorry.
refraction on both sides, like the
Yes.
terrestrial and celestial? Is that when they get closer? Like if they leave out the terrestrial, will it
If you
be
leave out the
further from the
terrestrial,
mark?
it's going to be a little off, but not very off. The
So
difference
you
between the
do
flat
have to
Earth
double refract it.
prediction,
Yo,
well, the difference
even
So
between
even
the
if they
flat
did,
Earth,
they still don't have a globe timing. They have our fucking timing,
I can give you globe
and that's our
timings.
premise, dude. That's why this is so significant, right? We just went through this whole circulation. Our premise was that they could only make up the difference in refraction corrections. We're going to use the true geometric position, et cetera, et cetera. Here we are arguing that, well, if we account for that, we can have your time. They're trying to co-opt our mutually exclusive time. All right.
Well, let's speak.
Are there any other questions
Well, one
before
other
I just
question from me. Let me just, not so much a
No,
question,
thank you,
just
John.
one more
yeah,
thing to
I'll
point
pass.
out.
too, bro? And like that kind of gave me hope because I have enough stamina to last for 2 John questions.
I can't be the only one who doesn't
I
care
have
about your question.
Yeah,
I
John, no
have
thank you. I feel like your
one
questions are
point to
bad
make,
faith.
and
They're
that
loaded
is
questions. Really, no
that
thank you.
I
No
you
thank
want
you.
are
I want John on the record
visually.
actually. Let me hear. I want John
No
everything John
thank
has
you,
to say
John.
about this on the record. John is a slippery one. He doesn't come by much anymore. He's been
Happy to talk if I'm
Slippery
allowed
hands. Go
to.
ahead, John.
We all voted
Go
no.
ahead,
You didn't
John.
hear me?
Lance, go ahead.
So
Mr.
I'll
Lance.
just point out once again. I mean, the thing is that
Again,
is it in
no
your
thank you, John.
okay? Never
Is it
I
a
mind.
have
new
a
question or are you
question
just
in good
pointing
faith.
something
When
out,
is the
man?
next celestial theodolite presentation? Is it on Tuesday?
It is Monday.
Ooh, not sure if it'll be Tuesday or the
Monday?
following Tuesday because I've got a lot to do in between in terms of stuff in real life and catching up to the new method of analysis and stuff so I can accurately discuss that.
I have a quick question about celestial refraction.
Yes, sir.
I remember watching Goose's presentation, and he was kind of talking about how the celestial refraction works against the globe. Could you speak on that? Because I didn't quite fully get it.
So I didn't quite fully get it either. Goose is going to be doing a follow up on it, but what it was showing, essentially, when you plot it out to scale, instead of looking at it like kind of scrunched up where it all has to, um, kind of line up, when you look at it to scale, it actually shows that it's like lower or something. So I don't know. I'm going to have to get with him to kind of further flesh that out.
And to
For
scale
sure,
means
for
1
sure.
meter per grid space on the simulator.
Yeah,
So like it's actually 50,000 something meters. The
to me,
distance. Yeah.
what it illustrated was how their correction keeps the star coplanar, like how we discussed earlier in the conceptual models of using the 2 spheres overlaid, the one of infinite radius and the one of the terrestrial plane. They uh, they apply that correction to keep it, they explain like why it's still visible and how it's still related to a ground position. So,
Right, right, yeah.
but yeah, to scale, it just makes it look like exactly like it makes it look extra coplanar. It's crazy.
Yeah,
Oh,
we're
and
gonna
anyone
have to
can
have Goose
join
do that.
the Aether Cosmology Discord. It's discord.gg/Aether Cosmology. And we're open to answering any questions at any time. There's a bunch of people around.
I look
So
forward to.
If
you
you're
guys can
not
join the
banned
Discord.
from the server like me.
Well, you
Yeah,
might be
because
if
you
you're a bitch.
suck.
Yeah.
You're just a sucky
No, there's no
person. You
promises to
got
not
banned
ban
because you
anyone.
suck.
Everyone's welcome, but if you're a bitch, you get banned. That's just the way it is. So about the celestial refraction stuff, that's a really cool. I like Goose's presentation. He built the whole model to scale in GeoGebra, showing how retarded the globe is and how all our observations and predictions are coplanar, which is excellent. However, he didn't go quite into the constants and how the equation was working, which you had to do because what Jesse was doing was just adding as much as he could to make it work. What he was doing was a process of correction and then calling it refraction, right? So he took a non-prediction that was the flat Earth elevation angle, applied celestial refraction with coefficients best fitting curve to plane in the math with all sorts of constants, figured out how to best fit it and just forced it in there. And that's the only way that you can beat it. So when you look at the math, the prediction that we make is based off planar trig. The prediction that the globe makes using either terrestrial or celestial is wrong every time. The timing corresponds to degrees, right? Because 15 degrees per hour ends up being like 4 degrees a minute. So when you break that out, the globe would have to be at a different time than what our flat Earth trig predicts, except our flat Earth trig is correct every time. So celestial refraction is a best fit corrective measure to take the flat Earth prediction and make it globe.
In Jesse's defense, he did apply the the globular protocol for the the prescribed coefficients to make the correction or whatever. So for
I don't
what it's
know,
worth.
man. The way I put it was like, he thought you pulled out the Excalibur sword to cut. We used to call him Refraction Jackson. He was like the last hero. And he
Refraction
cut his
Jackson.
like the movies. You cut him in half, and he just fucking spawns in the tube. Now they got double
Refraction
refraction.
Jackson.
Now we got double refraction, Jackson. Double trouble now. Gotta find another way to
And
kill
that's
this.
just because we're entertaining the idea of celestial refraction. Really, it's a category error or whatever because we've nullified refraction with the occlusion, right?
All right.
Yeah,
Yep.
that's why they desperately try to bring it back. That's why Dr. Heffron is a G and came up with a new proof, a new method, and convinced himself to be a flat earther as a licensed PhD senior in a community full of nonsense, right? So if that dude can do it, anyone can. Also, he put us all to shame.
I
I
mean,
haven't made a personal flat earth prediction proof or method yet.
it's
Cool, cool.
genies
Thank you.
versus wizards because now the wizards get to tell you that no, that was where you saw it isn't where it was. It's where we say it is.
That's like because they're including refractions or refracted shadows, whatever. Sorry.
To say how crazy is that, right? It's like they're comparing it to where a fictitious observer would see it under idealized conditions, and then moving the apparent position of the star, which is actually refracted. I don't deny a reasonable amount of refraction, but a coefficient output to curve fit what it needs to be to fit a model. That's where I'll draw the line. But um,
Yeah, like speak to that a little bit. I feel like there's like this really like they speak like we have such a great command on. Yeah, absolutely. You can predict exactly, what refraction is going to do to, something in the sky. And I just feel like with weather and all the dynamism and the
yeah,
atmosphere, I
so
just can't imagine that they can get that close to the mark. Maybe in smaller, in ideal conditions, but like the way they just throw
yeah,
it around, like move sliders around, I just feel like it's kind of ridiculous.
yeah, so it involves starting with a sphere of a radius of 3959, and then you're at the center of that sphere. This is what they're describing mathematically through an expansion series and integrating a data set into that, and then extrapolating out from that what the curve fit would be as you expand outwards from that center point of the sphere of 3959. And they created a smooth gradient atmosphere that's completely static, right? There's no dynamics to it. It's just a static smooth gradient with no, it assumes no changes in pressure, no dynamic changes at all, right? Just completely whatever it needs to be, so that it's modeled out to fit that curve. And then they apply observations to it, and then whatever the difference is, that's what the coefficient that comes out. And then they just apply that at those angles, and that's what it changes the star's position to where it needs to be useful for the coordinate system.
So it's celestial corrections,
It has
not
nothing to
refraction.
do. Yeah, and then so there's there's in one part of the equation, there's 3 different adjustable variables you can add. One is for temperature, one is for pressure. So what they'll do is they'll say, okay, here's some meteorological data from one night, and we're just going to apply this uniformly to construct the atmosphere. And then depending on how they do their integration, basically like how they assume the mass distribution of the atmosphere is going on at that time. Oh, people say they can't hear. Can you hear me now? Do I need to lean in closer? Is it louder?
It's all right. Can hear you if no one talks.
Let me see if my mic volume thing got adjusted. Give me 1 second. Because you know how Windows likes to play.
Yep. Oh, Windows.
Microphone adjustment
Nice. Welcome to the
simulator.
party.
1 second. Recording. Yeah, sweet. It changed it to 85. Hell yeah.
That's good. I mean, you're audible. It's just lower than everyone. We're talking about the radius 3959 derived from sun angles and an assumption or whatever.
No, we were talking about how the refraction coefficients keep the stars in alignment, or like, I'm sorry, how they were derived or whatever. But yeah, basically it's just derived off of computational models and doing an expansion series, and then whatever integrations they need to make it fit the curve so that they can produce a curve fit.
That's what it is, a curve fit. And on the lines
so in other words, when people are like, oh, well, Stellarium, it works, like that's the important part. It's like, yeah, but like, why does it work? You know what I mean? Like that's what I would consider an important thing to understand, is like, why does it work?
It's important to note that the globe not only fails at this prediction, but with terrestrial refraction predictions, the globe actually can't make a prediction. When we make an observation that we see too far on the ground, they have to know what? Everything about it before they can be like, no, dumb flurf, I plug this into Bislin's calculator and behold, just where it should be, right? We have to know what you saw, how much was missing, how high you were, where, and then we can plug in our coefficients to get our quote prediction, which is again an ad hoc correction. And the celestial refraction is even worse. So the globe can't make predictions with that.
Yeah, I don't know. I thought of a sports analogy. It's like we walk in the gym to shoot 10 free throws, shoot a few free throws, and we make the prediction, calibrate, pull, hit the shot, hit all 10, and then they go back and say, no, the rim wasn't where you thought it was, and the calculations to actually make it go in is actually something different. It's like, but we have it on tape. Like I walked up to the line and hit 10 shots. What do we do with that? Would we just throw that away and just go with your simulation?
Theoretically, all the nothing but nets actually were backboard.
Right. It's like, so what do we do with this now? Do I just sit it aside and get gaslit? Like,
Well, with Aries failure, they're like, oh, you know what happened was from the frame of reference of the ball, it actually didn't look like it was in the net. You actually went away from it, and that's how it was happening. So you're totally wrong. You just you don't understand relativity, stupid. Gaslight. What does anyone else? What else is going on in Flat Earth? We haven't been here in mad long. We always talk about celestial theodolite. There's other stuff, right? I heard.
Before we move on to
the
other
Man of
stuff, though, do
Stone
you guys have any
speaking.
other celestial theody questions?
Man, just give us just the update on I guess the numbers, the how many observations, how many peaks. Just a quick
Yep.
rundown.
So we got 9 now with Jesse's 2 new peaks, and I'll have to tally up the numbers, but I think the last tally for Mike's, just his alone, was 39 or 37 measurements. And then Jesse, I can pull up his spreadsheet real quick. I'll tell you what he totaled in.
Didn't you have some Czech people doing it too, or something like that?
We got a Canadian lad who's contributed, but he hasn't, because the way you can backwards derive the distance, it would dox him. So we haven't added anything to his or argue anything, but we got our own celestial theodolite, courtesy of the Aether Cosmology lads. Thank you. Shout out to everyone who's supported us. We got a
You bought it
Canadian
in the
lad.
store.
Yep. And then so we're gonna do our own observations with a C star and add to the data set.
No, I was joking. Everybody thought the celestial theodolite was like a special type of theodolite you could buy.
Yeah, apparently.
No, so that's a common misconception. It's just a recording device. So all we're doing is you just need something to record the star, and a way to synchronize your recording device with GPS time, so that you know where the star. You can work out where the star was in relation to time, and then compare that to the true geometric position timings and all that. So it's not it's not like a theodolite that we're like measuring angles with or whatever. It's a concept where we're calculating the angles based off of timing intervals.
Yeah, you can use any optical device, telescope. I think Heffron used a telescope for one point. You can record it. I mean, it's it's a conceptual device. People are like, where can I buy one?
All in one tool.
Can I buy my celestial theodolite? Do we selling them on Aether cause yet?
Dude,
gonna be a box with a card in it. It's like you're retarded or whatever. $20.
Like, so do I go to Walmart? Well, who was that guy we talked to on TikTok? Like, so do I just go to Amazon? And
oh, that was our geodetic surveyor friend. He was taking it in stride, but he was hurt. He had no answer. Dude, it's got other people all up and uproar too. There's a lot of people who can't under 69 miles per degree. They can't understand it, and there's a lot of people who make it about where it isn't, and then there's a lot of people who just don't understand the implications of the mutually exclusive evidence and the repeatability of it. So it is what it is. We try our best, but there's other stuff, right?
Oh man, I watched the one that I think Mattoon hosted. It was it Mattoon? Yeah, I think Mattoon hosted. It was on when Jesse presented his thing. I could see the moment when you kind of pinned him on like, man, so what did you input into your simulation? You put the flat Earth angle, right? And he kind of stopped answering, and you could see the whole body language got crazy. It was funny to watch.
Yeah, so McToon is actually going around answering. He's like, I have the answer to the celestial theodolite, stupid. I am the glober. And what he does is present Jesse's spreadsheet where he manually forces in 2 types of refraction at both ends. And he shows a clip of the spreadsheet and he goes, behold, proof, we win. And that's it. That's all he does. Now, the sad part is that's all he needs, right? Because his whole thing is to just grin confidently and make fun of Flurfs, and then everyone thinks that the globe is winning. So with this, if anyone mentions the celestial theodolite, he's just gonna like flash this broken spreadsheet and be like, "Gotcha." It is what it is.
I mean, but he's really short on rebuttals when he kind of pointed out that if you use the globe angle, like, why don't you try to do it with the globe angle and see what happens?
Dude, the worst part is he doesn't need rebuttals. Right? It doesn't matter. It doesn't matter that doesn't make sense. Doesn't matter that's fallacious.
Real quick, in his defense, he did update the sim thing to use the globe angle, and it produces the flat Earth thing. It produces the match with celestial refraction to make it match. So he did update it in his defense.
Well, let's talk about McToon.
Well, I know, but I was talking about Jesse because he did update it because we did. Like, he was using that or whatever.
Yeah, we made fun of him hard, and he went to work.
I don't think that was necessarily the trick. I think it was an oversight because what Mike pointed out about the sea level thing and the refraction correction matching the elevation, that seems to be like the actual trick because he didn't correct him on that when he called it out. So I think that was the actual trick. I think that the flat Earth angle was an oversight thing because he was able to do it after the fact. But again, only applying refraction.
But it doesn't answer anything or refute anything at all.
No, I know, but I just for posterity.
So like he corrected his like nonsense straw man thing that isn't a refutation, so that it can be better presented as a refutation.
Shout out to your boy.
It's sad that that'll work, right? Because they don't really need an answer; they just have to have that and some. What do they call it? First glance plausibility. That's all.
Actually, I would like to hear the response to John's questions on the theodolite.
Do you even remember what his question was? You have to repeat it.
Yeah, he asked about the celestial angle optically from the refraction and how he said the geometric azimuth would be different based on stellarium, and he compared from where the observer was at the house, which we answered directly and adequately in the very next statement, saying it's about the timing predicted by the math, not about the optical angle from the house, excluding the fact that the house isn't entered into stellarium, so it doesn't know the location of the observer, hence why the 50.7 mile celestial theodolite, 50.7 kilometer long celestial theodolite terminates at the mountain peak, which makes it the actual observer, which is why the occlusion is mutually exclusive. We answered it twice, and then he restated it as slowly as he could to elicit emotional reactions, and that's what he does.
You
kind of wanted him to do that, but that's okay, Shane.
Are you reading off a script
No, I have
version of
recall.
his
It's fine.
response?
I have recall. I remember what happened. I was here.
Dude, the most accurate 2-point summary ever delivered in 20 seconds or less. He's like, "Are you reading from a script?"
Off the dome,
Like,
out of irritation too, just to be, like whatever.
angrily answered it to recap as quickly as possible, so we don't have to sit through another slow rendition
Cheers.
of How I Met Your Mother.
Yeah, do you have your own questions instead of piggybacking off of John's?
If you have any, sir, I'm happy to answer yours or whatever.
Right.
Well, he has a very thorough list of questions.
No, he presented
No.
first glance plausibility in a Google Sheet image. That's cool. That's cool. He did some work.
All right. Well,
That's
if you
it.
want to rephrase his question in your own words, you can do that too. You're a big boy.
But and also, I'm interested in hearing the answer to his question, because, and particularly the one
Again?
posed to Saffron.
Okay. What was his question? Go ahead and repeat it.
Well, I have to look it up on.
Yeah. So you don't
his
even
Right,
know.
go
notes.
do that and then
I
come back.
do.
Yeah, so in the meantime, I had a question. Oh, matter of fact, yeah, my bad. My question was so the way I imagine is almost like you guys are just drawing like imagine like a filament or like a fishing wire or something, right? From the crosshair at the edge of the theodolite. It's nice and taut, straight to the mountain peak, and then to make the prediction, and then nice and straight from the mountain peak to the angle, that the star is supposed to end up behind it or whatever time, and they have to bend the first filament in a real ideal way, and then also bend the second filament according to two different refractive indices or equations. And I'm just wondering, does that make the mountain like some arbitrary threshold, or how are they? Is it? I just don't understand how they're working in the two refractions. How they calculate it.
I think
Are
it's
they
at this
calculate real
point
quick? I
just
guess the
Because
question
it's
is,
supposed to be
Jamal.
my fault. Are they using the refractive conditions from the peak to the star or from the observer to the star for the celestial refraction?
No. It's just a correction. It's just like a post hoc correction to make it fit back into the globe again.
But does it require the position of like, and which position do they use, Heffron's house or the mountain peak to star?
No, see, if it was an honest approach, they
So
would have
that's
their
where the
own
globe.
timings, but they don't.
That's where the
Right.
globe. Can you hear me? Is my mic going
Yeah,
off?
there you go.
Not
Yeah.
great, but yeah.
Yeah, so the globe predicts two different locations for the stars using celestial refraction based off of those, and then also two different for the uh, true geometric position or whatever. So when they apply it on either end, like they can get close, or like they have to invoke enough refraction to always co-opt our position. They never have their own timing, just using the raw geometric position
It's
and the
not
raw
true.
trig angle.
You're just lying about our method. Now, I can predict the time. I don't even need to include terrestrial refraction, and I'll beat the flat Earth prediction.
You don't hear a mosquito fart? I haven't turned down.
Alan, is that you?
I'll be right back, Shane. I'm gonna go grab some water.
You got an example of that, John? You got like something to
Yeah, I
show?
put a couple of links to sheets showing that Heffron's own data shows that at the time that he
Did you say
saw, so
Heffron's
two
data, so
things.
not your own?
Heffron's data, yeah, I'm using
Okay, remember what we
Heffron's
just
data.
asked? We asked for your own timings, your own data.
Yeah,
Remember?
nothing post hoc. You
Yeah,
can't go post
no,
hoc on it.
I can tell you how I would have predicted the time given
So
where
you don't have your
Heffron
own
was
timings.
making his
Okay.
observation
Yeah, but John,
and
that is
what
post
peak
hoc,
and what
right?
star.
That's
It is, I get that, but the
so
point
that's
is
How
I
is
not
that
can
a
do it. You
prediction?
tell
or it's
me,
valid. Is
you
it?
give me a star and an observer location, because you have to know the observer location,
No, you don't.
and
We
a
don't.
peak.
Only you do,
And
because
yes,
your
we
position
do.
is
You
weak.
cannot tell when an occlusion happens unless you know where it's being observed from.
Nope.
John,
That's
how
just a
can something
Nope.
simple,
post
All right.
hoc be a
obvious
In the
thing.
prediction,
arctan of
John?
rise of a run distance, in the equation that you predicted, the only two parameters are distance and it's only the distance, right? So when you're using the actual formula, you're not gonna use the location. You don't need long lat. You don't need where the person is. You only need how far away from the mountain it was. That's what we're predicting it on. That's why it works for the mountain, and that's why we don't argue that it's not optically the same from the house. That it's irrelevant. Everything you say is
The
about predicting the
occlusion
optical
of
timing, but your
Shane, he already
optic
cooked himself.
refraction doesn't preclude a
occlusion of
timing,
that
right?
star by that mountain at that time
At that location.
occurs only at Heffron's
Yeah.
house. Only at
All right,
keeps
Heffron's
he
one
keeps
house.
second.
How
saying
can I?
Hold on 1 second. I gotta run through this again. I guess I can't take a quick break
we let him speak.
No, you
before
don't
we
have to.
start.
You don't have to. He just admitted that it was a post hoc explanation. He literally just
No,
admitted
no, I
that.
know, but I'm just gonna reiterate how ours isn't. Right? We only need to know what peak occluded the star at what time. We don't need to tell Stellarium or
Right. And
intermediate
that tells
distances.
you that
We
it was
shut up.
observed from
We can
Heffron's
backwards
place.
derive the distance. We don't need, or like we can make the actual prediction. You can make the post-diction. Your
John wonders
And
why
how do
he's
you
position,
banned.
get the
your
time? How do
your
you
continual. Don't talk
get
over me,
the
bro. Hey,
time?
John, do not start speaking over me when I'm talking though. Like we'll let you talk forever and shit, but when I'm talking, don't start immediately talking over me. That's the most annoying goddamn thing in the world.
Which
So
is
as
his
I was
point.
saying, we make the prediction, you make post-dictions. That's it. I'll be AFK now. If you go on to say, well, blah blah blah, you can't do it, you're now just lying.
The
I'll just say it one
time,
more time. One more time. We only need to know what peak and what time, and we can backwards
right.
derive it.
Yep.
You
How
don't
high the
need to
mountain
know
is and how far away
everything
it is.
else.
That's it.
You need to know
And
where
the
the observer
star.
is.
And the star.
You get arctan of rise over run, right? So
Enjoy your post-diction.
2,226, 50,000. That all you need
You
is the
need to know the
distance and the
peak.
height.
You need to know the peak, the star, and the time.
This is getting real
That's right.
desperate, brother. This is
Yeah, I
getting
just
real desperate.
the whole point is let me just keep
No, but
repeating it
let's
and
be
then
perfectly
try to
clear for
instigate.
anybody who's is it my turn?
Yeah.
Let's be perfectly clear for anybody who's listening. The that star is occluded by that peak at that time
What a
at
fucking
only
statement.
one place. And so if you're going to start with the time, you have to observe it at Heffron's place.
Incorrect.
That is in there. It's in the mix. If you
Nope.
didn't know that it was Heffron's place, it wouldn't be that time.
Great. I'm glad you
So
have your ad nauseum filibuster argument. Thank you for contributing, John. But
right.
also, you're wrong.
But just to be clear, we never use that. We only use the distance and the height of the mountain in our prediction, and then we go to Stellarium
It's
and we plug in where the
unbelievable.
mountain is.
It's
That's
just
methodically, logistically, and
unbelievable.
mathematically how we did it. Only you need to know where it is. Anyway, moving right along.
Okay, I'm out of here, gents.
Later,
Laddies,
John.
lads, and ladettes. I'm out of here.
We'll miss you.
Wait, before you do leave, John,
Oh,
I'll
dude, what are
address the
you?
question.
What are you doing? One
Maybe
more
he doesn't have to
thing.
talk more. Well, whatever. I wanted to address. I saw Taylor post that dope video with like the water and the laser and like showing that you can't have the refracted image block the actual position of the actual angle. Like, does anyone have a link to that? I saw it like somebody's
We were looking
presentation.
for
I
it
don't know. If she,
yesterday.
It's a downloaded video.
okay.
It's in Discord.
You should post it on YouTube
Um,
somewhere, dude. We should definitely. We couldn't find it for a bunch of times. We really need it. It's a good example.
yeah, you should just have it in the arsenal.
Yep. But yeah, dude, what are you, Columbo, Jamal? And wait, one more thing.
One more thing.
Nah, I just kind of wanted him to. I just want to hear him say it, like, get as ridiculous as possible. I want to hear him articulate it. Like, tell us exactly what it is you're appealing to. You want.
Well, his method is effective because there are people in the YouTube chat who are like, "Why don't you let John speak? He must have a great point." It's like, look, the whole point of him doing that is to elicit the emotional response that we gave him, so that people can claim that, right? And that it is what it is, and we don't care.
Yeah, no, I think you guys are moonwalking around his point, but for a good reason. You feel me? Because it shows that you guys are finessing the work, right? Because we know in reality, even if, right, you choose the same distance from the mountain peak and create that radial circle, right? If you change your position, that changes the azimuthal direction of the star. because you're changing your different perspective to the mountain peak. We know that in reality. So I think his point is valid.
But it's not like the observer location isn't entered into any of the math, into the formula. It's not put into Stellarium. So the argument
Bro, you
that
don't have to
refract,
put it into anything. It's
you don't need
already
it.
known
No, it's
because
not.
we
No,
know
no,
in reality,
it's not
right?
known.
In reality, the reality that we live in, that if you circle an object, right, you change your perspective to that object. And if there's a star in question, right, you're changing the azimuthal direction of that star based on your direction of your observation.
I get you, man. I understand. But answer me this, right? Where is Heffron's location in arctan of 2,206 over 50,700?
It's in the angular
Ooh,
position of the
nice.
star. The angular
No, no,
position
no.
of the
That's
Yeah,
the
yeah.
math
star,
that we
once
predicted.
you back
Where's,
derive
come
the
on.
math, it leads
Where's his
directly
location in that
to
formula? He just stated to you.
Where's
Where's
Heffron's location?
yeah, where is it?
it's like I said, it's in the angular position of the star. It's azimuthal direction.
Nope, because
You can get
we get the elevation angle using just what I said. Arctan of 2,226 over 50,700. That's
Is
it.
that 2,000 number the elevation? That's the peak.
Yes,
yeah.
altitude of the peak.
And keep in mind, you can, and this is for all the marbles, right? This is for prediction versus post-diction. We could backwards derive that distance if we know the peak and the time that it was occluded.
Right, so the timing is the prediction. Nothing about the where the observer, when Heffron tells this refraction from here to there is irrelevant. Prediction is arctan of 2,226 over 50,700, period. Only on the globe prediction are you allowed to, add and correct. And even then, it's still wrong. It's still off. And it's off every time consistently, no matter what. Using this method, meaning you're not worried about the optical elevation from a different, you're only worried about from the mountain and the time. That's it.
Like, do you get that, Paul Coffey, that the prediction is based off of a raw, just trigonometric angle, prediction or value or whatever?
Yes, but the star in observation, right? Let's say we're choosing the mountain peak as the occlusion point of that star, right? And if we circle around that
No,
mountain,
that's the
right,
location.
the stars direction, it's an azimuth and declination time. It changes.
If we go to where
Okay,
the observation wasn't made, then yeah, it changes. Yeah, it's not really a good argument. Like what
Arctan,
is this argument?
2,226 over 50,700.
Like what the fuck are we talking about?
That's it.
and
Everyone who
like,
says you need Mike's house, where? Show me where.
right, because it seems like it's literally not in the math, which is like, let's say, like
Bruh,
the
you
analogy I use
just
real
said
quick
it.
is,
He
it's
just said it. So once you change your position from Mike's house, right? If you understand that this is reality, the timing changes once you change your position from Mike's house.
How could you
You don't
yeah.
get
possibly
that same
conclude
Here's the
that?
angular
thing.
position.
Yeah, go ahead. I was just gonna say, like, qualitatively, right? Yes, there's something. I get what you're saying, right? The observation is being made from his house. However, we're using a predictive math model, and the planar regular triangle math model requires less input to get the same output or better output, actually. But let's just take for granted that we both hit the same bullseye if they put it in their post hoc, math fraction. With this, we can use less input and get the same output. By definition, it's more efficient. No.
And
Well,
predictive.
I think we need a
Bruh,
middle
if
ground
I'm
here,
observing a
perhaps.
star, right? We know
Hold on one second,
stars
Coffee.
motion.
Okay,
Go ahead,
I
my
got you,
brother.
bro.
Go ahead.
I got you. So I think what's being overlooked here is we're not saying like a 360 degrees around it, right? It would be like along an arc to the mountain, right? It would be occluded to a certain point for an
Maybe
observer
like a
along the arc of
slice.
that. Is like as long as they're at that distance along that arc. Is
No,
that fair?
Either
it
way, what does
it
that have to
doesn't
do with the
work. The
argument?
reason it doesn't work, right? We know that a star's motion, right, is about, I think it's a quarter degree for each minute, right? So even about, let's say, a point 0.1 degree shift, right, should attribute to about a 20-second delay in timing. So if I
Oh,
switch my position at least a point one a degree, right, my timing is off. The timing and angular position directly correlates to Mike Heffron's house. And I don't get how you guys are not seeing this.
That's not true because you can use another set of long lat, let's say 53, 59, and then 42, 53 west, which is a antipodal point away, which is 50.2 kilometers away. And guess what? Dude, the math is exactly the same. It's the distance that determines it. The position of Mike's health isn't relevant. You're making an optical argument when we're trying to exclude the optical sightlines. That's the only position the globe has, though. So we forgive you, Cock. And also, you're not super annoying like John, even though you are trying super hard. Respect it.
Saying respectfully, you're just saying words, right? And you're talking real fast because we know this relates to reality. This is what's observed.
No,
We
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 used a
just we
different
just
location. I just
if
did it.
you agree that a star travels, right, about a quarter degree every minute, then this is undebatable. If we observe this in reality, then there's no need to to even argue this, my brother.
Puffy, did you say he's just saying words?
Like that one.
Yeah, that always gets me on a fucking audio app. Like, should I just make like a series of grunts or like dance or sing? Some shit like that? What the fuck am I supposed to do?
But dude,
But
I
all right, so
just
I'm
use
thinking of like,
grunts.
Bruh,
so
it's the equivalence of what Ghost I don't know if y'all are familiar with Ghostface Killer, but what Ghost used to do back. So what Ghost I don't know if y'all are familiar with Ghostface Killer, but what Ghost used to do back in the days, you feel me? Just to
just
throw out
saying, man.
bars out there, you feel me? Just to
No,
rhyme
listen. So here's
with
what
no
I'm thinking, right?
connection in between them.
Imagine a
Like
split
you
screen,
feel me?
right?
There's no cohesion, there's no glue.
Imagine a split screen, right? We got two Dr. Heffrons, right? Two different. One is a global, one is a flat earther. And the thing is, he's going out and he's making these timing predictions. One with a planar assumption, the other with a globe assumption. I'm trying to figure out how he would actually make the prediction. Let's say he has, all he has is like an almanac in front of him. I don't know. I'm trying to figure out how he would even go about making the globe predictions without having, because to my understanding, the data points that went into making the globe and the graticule in the first place kind of require a tangent, like a plane, right, all the way 360 degrees to the horizon. So how could you dismiss the planar data and like model? I just don't know. It's just, I don't know.
I think they
If
know
you can help
that.
me out, huh?
I think they know that.
Yeah.
I don't really like the argument, you're just saying words, because, you could just say that back to the person, right? You're just saying words, and you just say, you're just saying words. It's just filler. It's garbage. It
you
has
No,
say
it's
nothing.
like a
you said
go-to
better words.
NPC response. Is like all the words you said equals zero equals nothing. Your words equals nothing. Like you
Man,
said
I
nothing.
heard
You could
nothing.
say the
yo,
most. Yeah, like it's just do that.
because they keep
For the
saying
most part,
it.
when people do that, you're just saying words, or that's word salad. It means like, I don't understand what you had said, or I'm not going to grant what you had said. But most of the
Or I'm
time,
not
they don't even
listening.
understand what was said. They can't even repeat back what was said. So you're just saying words is not a very compelling argument.
Because everyone keeps arguing, I've been plugging in different lat long into the distance calculator to supply in the bottom half of that triangle for the calculation. And guess what, guys? It keeps working. So Heffron's
No
house is
way. It's the same
irrelevant. It's
triangle?
crazy that
No
this doesn't make
way.
any difference whatsoever. So there's a benefit. There's
Right.
some more
Oh
coordinates.
no, there
So
he
so
goes again saying words.
so back to the split screen. So this is the thing I'm thinking. So let's say I didn't
Bruh.
have an entire coordinate system or map to really even have any way of signifying my specific location. All I had was a way of like an angulometer, a way of measuring the angle and something, related. Let's just say I had the data just for this one star. There was this one light in the sky that I had the data set for, and I didn't really have a whole coordinate system to give me a longitude, latitude, position to work into some greater predictive model. I was literally just looking at the data for this one star. And what would the globe do? How could a globe like this? It just seems like you said, like a post hoc thing that requires having all of this planar data and then fixing it, and fixing it for a coordinate system. It doesn't really seem like something you could make raw, that you could just, that could just match. your observations.
Dude, that's how the globe works. That's how geodetic surveying works. That's how everything works. Right? They take flat elevation angles and then they comport them to a model, whether it be geodetic datum of WGS84 or the refractive correction for the globe radius or what have you. That's all the globe is. Actual observations corrected via model and math.
And it seems like this
Shane,
method really blows the lid wide open on it.
hold on, Jamal. You know why I know you moonwalking, Shane, my brother? I'm gonna tell you why, my brother. Because you
Moonwalking,
gave in the simulated longitude and latitude coordinates, right? But
it's
none of those
simulated.
have anything to do with the 360-degree position around Mike Heffron's uh,
They're
Pike
all
Peak observation.
they're all the same
It
distance
doesn't.
away from the peak, though. That's exactly
Yes,
related. That's what, yeah.
exactly. But that's not his position.
Well, they're
His
closely
position
related.
is Mike
I'm picking
is
points,
50
right?
kilometers away from Pike's Peak.
Well, you're
And
saying
if you
it's
change your 360-degree position arc, right, along that arc, you change the timing, right? We're not talking about changing his direct location, right, to a new longitude and latitude coordination. Not at all. We're talking about moving his position along that 360-degree arc around Pike's Peak. Once you do that, you change the timing because
well,
of what we observe in reality.
our
It's just plain and simple.
our argument is anyone, right, who can see the mountain who's around 50 kilometers will make the same observation. And I picked coordinates on the other side, changing the azimuth and direction, which had no bearing on the predictive math. So I don't know what you're talking about with the arc thing, but what I think you're arguing,
Yes, because the longitude and latitude coordinates bear a specific direction,
yep,
right,
the bearing, the
to
final
whatever you're
bearing to find to
observing,
look for it.
right?
Yeah.
And once you change that position along a 360-degree arc of a center point around that longitude and latitude, you change that longitude and latitude, therefore changing the timing of whatever you're observing.
Well, the
Works the same with
distance.
Mike Heffron's Pike's Peak.
Well, the distance is the
Keep
predictive
keep
part,
the
right?
difference
So
keep the
that's
difference the same, right? Keep the distance the same, right? Let's create a radial line, right? From your observation point, right? From whatever coordinate that you choose that matches, right? And in that center point, as soon as you move in an arc around it, right, you change your longitude and latitude coordinate position, but the distance remains the same. But you know what else changed? The star time and occlusion. The star occlusion timing. I'm sorry, I said that backwards. So the point still stands. You feel me? This is observed in reality. I don't get how you guys don't see it. You guys should
What are
see
you
it.
talking
Hold on,
about?
wait.
The time
What is
change, bro. There is one occlusion time. One. That is it. Why are you adding
yeah, like,
another one?
but let's just grant you that, okay? What is your point? Where's your timing? Where's your observation? Where's your
Bro,
celestial
my point is,
theodolite
I don't
timing
need,
occlusion to show that the globe
I
is
don't
more
need, I
accurate
don't
than the
need
fellow
any of
plane?
it. You feel me? It just took an
Oh, you can just
observation
hand
of
wave dismiss it.
experiment
Okay.
to see
well.
that it just didn't work. It's a globe Earth observation.
So the
I
flat
think
Earth
that the
again.
occlusion time actually changes.
It doesn't, right? The
Do you actually think
prediction
that?
arctan of 2,226 over whatever the distance is. All right, in this case, 50,700. It has no idea GPS position. This one doesn't even give you a bearing, right? This is just determining the distance. The predictive power comes from the distance, not from GPS long lat. So anyone who can see the mountain gets the same occlusion timing. That's the argument. And the prediction doesn't change. You have no prediction of your own.
They could
All you can
all
do
see the
is
mountain
speculate.
peak, but do they see the same star in the same position, given their position? That's the question. Because that would change the occlusion timing.
Well, it doesn't, because optically it doesn't affect the timing, right? You can't something that's refracted or not observed can't occlude something. The implication behind this actually is that the way we see things with refraction and optics is different than how things are in reality, right? We have the visual space and the visual field. There's some high level math papers on Euclidean versus non-Euclidean and the curvature of visual space. We talk about it a lot, but what's behind this observation is that in reality, in the visual field, where that star is, it's the same for anyone who can see it. Anyone who's looking at it though will see a different refracted angle from where it is, but its true position gets occluded. That's how the experiment is designed. That's the part to focus on, and until you guys can refute that timing, nothing you say matters really.
But Shane, you proved it yourself, my brother. You had to simulate coordinate positions that weren't along the arc of that mountain's peak to find a relation to the observation. Now, once did you simulate a coordinate position along that 360-degree arc? It was across the world, I'm sure. You feel what I'm saying? That's why I have the disconnect with it. You feel me? I honestly think it all boils down to whether the horizon dip. That's all it boils down to at the end of the day. It's gonna be a how can I say, age old question.
All right, so kind of like I was asking, what do I do with the footage of me walking up to that line and just shooting the shots and hitting them? It's kind of like my question: what do you do with the fact that just raw trig can in just a distance, like literally, all I have to do is be a flat earther, start from point A, 1 foot over the other, get the distance to the peak, say, all right, walk back, and then measure the angle, do some trigonometry, keep my flat earth stubborn assumption, and then I can keep making the prediction and hitting the bullseye. What do I do with that? What do you do with that? Is what I mean to say. What do you say to that? Is that or is that not the case? Is it something I'm misunderstanding here?
No, I like that analogy.
No, I would say that your observation looks to be on an L, you feel me? But the lens that you're seeing it through is off. You feel me? And it all goes back to whether we're correlating this to curvature or not. That's all it goes back to.
I think you just
You're
said it.
technically
Bingo.
hitting the. You're actually just hitting the backboard, Jamal. You're not making those free throws at all.
No, it's equivalent to saying, right? Let's say Jamal's out on the court and he's gunning these shots, right? And he comes to me, he's like, "Yo, I was gunning these shots on a regulation court." You feel me? We know regulation is like 10 feet, 10.5, right? And I go over there and we do the math and everything, and I'm like, "Well, you didn't correspond for this dip in the surface of the floor, and that court in relation to where you're shooting is only about 6 feet." You feel what I'm saying? And
No,
he's like,
because
"Nah,
the
it's
analogy, to keep the
actually
analogy
regulation."
going,
And I'm like, "Nah, it's 6 feet."
is this, I'm not predicting this off of feeling. I would be like a fucking robot that you put the programming in, like that little Japanese robot that shoots the shots. So you would go and see my data. No, I actually factored in for a regulation shot. How'd I keep hitting it if it wasn't a regulation hoop?
And it doesn't change. I just realized that the bearing is the bearing of the mountain. When you plug in the long lat coordinates, the long lat from the bearing is from the mountain. The mountain gives the same bearing for everyone. So I don't understand your point, Coffee, but I do appreciate the effort.
Bro, you're gonna make me take a second and do the math. Give me a second. I got you. One
Well,
one
have you
second.
not looked at the
Uh,
spreadsheet or the math up until this point, bro? I'm
now
gonna
I'm
be
gonna
super
put this in the
pissed.
bag. Two seconds, my brother, because I ain't got time, bro.
Don't tell me
I
you
got
For
haven't
the
you.
looked at this yet.
multicolored line graph, that was
Coffee.
What? What? You haven't
Yo,
He
looked
said.
at it
what
once?
the rock? Yo, did we
He
just
said,
get
I don't
coffee?
have time. I don't have time to look at your spreadsheet. Let me make mine.
You didn't just
Yo,
say
I think.
that.
Oh man, that's all right. Does anyone else have any questions?
How good is your free throw percentage, bro? What are you at?
How good can I make you think your free throwing was, though?
I love that new analogy. Good shit, Jamal.
right.
Naturally, I have questions, but I don't think
Oh,
the
time to
answers are
go. Gotta go.
available.
It's time to late. What's up?
Yeah, no, thank you.
What's
What's up,
up, Jesse?
Jesse?
Wait, who was that, Jesse?
Yep.
Do you guys
Is
know
this the Jesse
what's?
from? This is Jesse from the live that I was
Hey,
just talking about
uh,
with McToons.
Yep.
unrelated. Does anyone know what smarmy means? Or how about
Say it one more
unctuous? Can
time.
Now,
someone
now.
define unctuous or smarmy?
What about prevarication or obfuscation?
Those are good ones.
Unctuous, I know I definitely knew that at one point. It's escaping me now.
Everyone should look it up. Is all I'm saying. Unrelated to a new member.
I
I did
would
have a
say that
question.
smarmy means ingratiating and wheedling in a way that's perceived as insincere or excessive.
Insincerely earnest. Yeah, exactly. The worst.
Jesse, did you
I
say
was
you had some
curious.
questions?
Yeah, I was
Alright.
curious if any of you have tried out Dr. Heffron's correction method on any of the data points yet to see how it
I
works.
have not.
Do you mean in the simulator, Jesse?
No, he's talking
No,
about the new thing that
the method
Efron
that he
proposed for the
set
analysis.
forth on Monday.
Oops, can you
I've
guys hear me?
checked
Oh,
4 of them, and I was wondering if anyone got different results than I got.
I haven't checked any of them yet.
What's that?
I haven't checked any of them yet.
The Jesse is much louder
Okay.
than you.
Yeah, I'm on this dumb tablet, and it's turned. Oh, I just turned it up. I bet I can hear you better.
And my mic's really low. I'm using a laptop mic at the moment.
Oh, I can hear you good now that I turned my tablet up. I had it turned down for some reason.
Hey, what happened to Battle of the Beams? You guys never addressed that one. You just waved, just hand waved refraction, right? Kind of the same thing.
From what I remember looking at the data sheets that you guys provided, they actually did show minimum usable altitude levels versus distance that actually did look like the Earth was curved. That's just my vague memory from looking at the data sheets when everybody was talking about it.
Wow. Okay. I vaguely remember that one time there was some data I could have created a curve from, and one of the I love it.
Yo, I actually think Man of Stones, the sunset, the angles, like I feel like that's super slept on. I feel like I haven't seen any really good. I mean, aside from Man of Stones with the glass through his window, I would like to see like some people who have a really good vantage point. You just doing like sticks and shadows, like a like a wall. Just have like a nice cement wall, clear, everything really controlled. I would like to see that.
that one's great. I remember Coffee's response too. You ever heard of Twilight
Oh,
Refraction?
Twilight.
Yeah, I'm gonna speculate on some totally new phenomenon I think might help me here. I'm gonna throw it out there.
Hold on, you just stopped me from my work. When the hell did I say Twilight Refraction?
Bro,
I don't know what you
that's
called
exactly
it.
what I remember.
Yeah, it was something
Yep.
crazy. That was good.
We gonna come back to this in a second. I got you.
The globe model, you guys can't speculate, right? You have rhetoric, you have dogma, you have to refer to the scriptures, you have to go to the priests. You can't actually come up with a critical analysis on your own of how you think things work. That's not how the cult works, right? Unfortunately. We can come up with creative solutions and then tell others, and hopefully it catches on, right?
All right, so now that y'all have all of this shit laid out in front of you, pretty much have all the fucking cookie crumbs leading back to the jar, and like you see the whole reverse engineered like scheme. You gotta admit it's a hard fucking sell to sell people that there are people this clever or that they really wrapped up a fucking deception this tight. It's a hard
Dude,
They
sell.
did,
Truman
bro.
Show, man, right? You accept the coordinate system with which you're presented. Everyone thinks they live on WGS84, the geodetic datum, the ellipsoid model constructed out of nothing and assumed from the get-go, confirmed only with minimal meridian arc measurements. Crazy, but it's a hell of a scheme, and it works really well. Talk about first glance plausibility, man. Dude, everything
Doesn't even
mapping,
lie.
directions, satellites, planes, it all conforms to the geodetic datum. So people would think, oh, that must be the surface of the Earth, right?
Jaren says it matches every single prediction. Everything.
I would like to hear a globe
Dude.
point from John that isn't fallacious, though. One time, someday.
No, I said Jaren.
Oh,
I heard
oh,
Jaren's debate with was it?
Was it?
Galatrix, what's your new argument that's similar to Jaren's? I hope he's there. He might not be there. Basically, I don't know if you guys saw the Jaren debate, but he's just affirming the consequence. The globe dictates a 24-hour sun. I saw the 24-hour sun, therefore globe.
Yeah,
Well,
but
in
I
globular
like fish
defense,
sticks. That makes
in
me a
glo-
gay fish. I eat fish sticks or some
in
shit.
globular defense, though, right? So we've got this stitched together coordinate system that makes use of the fictitious observer. The only thing, if you assume that the sun is physical and place it at x distance for your conceptualized model, using Kepler's laws and what have you, right, to construct heliocentrism, if you had to explain the 24-hour sun, Earth curvature is it's super easy. You've already linked the thing. It's just adding. You're just assuming physicality to it now. So like that is what it is. That's it. That is what is in question. Now, the globe, right? Remember, was derived off the position of the stars and sun. So of course that's going to match. Like, is it a prediction or is it a post prediction?
Backbone of the model, one might
Right.
say.
Oh, can you guys give a microphone to
Piezo? Is that Piezo down there?
Piezo? Yeah, piezoetheric.
I don't know how to do stuff.
Oh, we got another one of
What's
John's disciples, John's boy Hero in the chat. Hero, you got any questions or comments about the celestial theodolite? I don't know if y'all remember speaking to him before. Peace,
Yo,
there?
Piezo.
Yeah. No, there's Piezo.
I'm glad you can hear me. What's up? I got in here a little late, but I got the bat signal. So
Nice, dude. I love Clubhouse's audio feature where it sounds like everyone's in their own space of the room. I don't know if you guys noticed that.
Yeah,
Piezo, you sound like you're in the deep
connection.
left.
Yeah, you're underwater?
me?
No, it's just I think it's just a feature of Clubhouse, like spatial audio. It's pretty tight, actually. Pretty smart.
Oh, I finally disabled it. Now I can hear normally. God bless.
What did you disable? Hold on, where do I go?
Yeah, but that quote from Copernicus, coming from Copernicus, is dank as fuck. Where he's like, so far as hypotheses go, let no man expect anything from astronomy or something to that effect. I think I hit it on it. He says, because it can't produce it, And if you
I
do
think
accept anyone's explanation, you'll leave
Oh
a
yeah,
bigger fool than you came in.
I think he
It's
said
like
anyone
coming from
right
the
can.
here,
man himself who put the fucking ground in the sky flying around. That's kind of dank.
dude.
Ready?
Coming from the man himself in 1543, he says, but since for one movement of varying hypotheses are proposed from time to time as eccentricity or epicycle. So he's talking about, we can do a geocentric model or we can do a heliocentric model because one was based on circles, one was based on ellipses. And for the movement of the sun, the astronomer much prefers to take one which is easiest to grasp. Many philosophers demand probability instead, but neither of them will grasp anything certain or hand it on unless it has been divinely revealed to them. So he's saying, like, it doesn't matter how good we think about it or conceptualize it, we're going to go with what's easiest to understand. And the only thing that we'll ever say for certain is if it's been handed to us by God, right? And, like,
Well,
no one's trying to say that because that would be some blasphemous Joan of Arc stuff or whatever they kill her for, right? So then he goes on to say, therefore, let us permit this new hypothesis to make public appearance amongst the old one, which are themselves no more probable, especially since they are wonderful and easy to bring with them the vast storehouse of learned observations. So he's saying if you use my eccentricity model, my are based off of ellipses, uh, you can have the really easy teaching tool that encapsulates all of astronomy, which is just predicting the positions of the planets based off of a ratio of pi and periodicity, and it's not a prediction; it's an observation. So that's just taking how long it takes for that planet to come back to the same spot and then multiplying that by pi. That's a really truncated version of it, but that's essentially what they're doing. And then he goes on to round it off and say, and as far as the hypothesis goes, let no one expect anything in the way of certainty from astronomy, since the astronomer can offer nothing certain. Lest if anyone take as true what the astronomer has constructed for another use, he will go away from this discipline a bigger fool than when he came into it. Farewell. And my favorite part, he hits him
nailed
with
it.
the classy farewell.
Yeah, farewell. That's right.
He's
Take,
like,
you could be an idiot, after, I said it, as you're responsible for it,
Dude, I'm out.
yep.
I'm
so
not, imagine that.
so
The back.
basically,
Sorry, go ahead.
go ahead, Shane. It's all right, man.
I've been here all night. You just got here.
I was gonna say he's basically saying like, look, we made this system to try to develop a way to predict and measure stuff in the sky by, thinking up of a model of Earth being this ball that we see the sky being, but don't confuse the purpose of our endeavor with some kind of other physical meaning, or else you'll end up being a fool.
Yeah, but it seems like sort of a warning, right? Coming from, like, you must have seen trend or tendency toward people, using these predictive models to captivate people and tell them tall tales and shit.
And now everyone is certain what the
Well,
stars are made of, where everything is, how far away it is, what it means, what the galaxy is, when Andromeda is going to collide. Dude, the amount of certainty in the model is horrendous based on this is the backbone, right?
well,
Yep. I
and
mean,
that's
they
exactly
weighed it.
what was it. That's exactly what was at stake. Yeah.
What
They
about
did you not know
claims
they
that
weighed the lights?
they radar range the sun and Venus and all this?
Dude, if you look into that, that's crazy. They invented the tech for it, then they invented the receiver, then they got one signal back, then they guessed about the distance. The process all through like that, whatever the 80s, it took like a decade. They published patents on it. It was ridiculous. It's a ridiculous thing. Anyway, I looked into that once and I was like flabbergasted. I was like, this is the proof of radio waves to the sun? Great. Everyone should look into that.
I mean, dude, it is totally possible that the moon could, or wherever the moon is located in the sky, could be producing some kind of electromagnetic surface or something. Like, but the whole laser beam bounce thing was really crazy. I think that's crazier than the RF thing.
But lasers could do that before, though, right? So lasers is one thing, but with the radio wave, they were confirming, quote, measuring the distance to the sun. They were like, "Behold, 93 million miles." That's why it was ridiculous.
Oh no, but I said they claimed that the reason that the lasers work is because they put mirrors there that you can't see because they're too small to see.
But
They
how did
know
they do it
exactly
before?
where they are.
Did they do it
Right.
before the moon mission? Then, if that's what's doing it.
Also, I would challenge anybody to use a GPS or a DGPS antenna and receiver and shoot a DGPS wave straight at the moon and then wait for the receiver to get a bounce back and use the range measurement equation and show me that it's 250,000 miles away. I'm waiting on that one.
Yeah, all they get is the angular distance formula to get the measurement, which they get, based on the optical diameter, and then they just plug in the diameter of the actual thing and the distance that no one can measure to get 0.53 degrees to equal 93 million miles. That was the whole guess with the scientific method as they went through all the scientists predicting the distance of the sun. They would just plug it in
Right,
differing radiuses for the same formula.
Well, dude, the stuff you can get on the open market, like amateur DGPS receiver equipment, is way more precise than anything that they had back in the 60s by like orders of magnitude. And you can just buy it. Some people have it as hobbyism if they've got cash like that. Any of those people at any time could do the thing I just said. I'm still waiting to see it happen.
Used to have some dudes in like the Gulf, like some Arab dudes who used to do it. And he'd come back saying it's you get back nonsense, random things. Sometimes you might get a 50-mile away moon, sometimes 5,000. You get different things. You never gotten anything consistent with from his experience.
Shout out to those
Actually,
Arab dudes.
Or could you somebody kind of help as visual as you can or like as clearly you can break down the two sphere model, like the two hemisphere model,
Ooh,
like
that's my thing. Dude, I'm doing a new presentation on it Tuesday, I think, on the amalgamation of how like the whole globe model is the two-sphere model, which is based on Ptolemy. But Ptolemy's two-sphere model was his epicycle and geocentric circles. But what his impact was on cartography was the globe, right? He created the two-sphere model of the celestial sphere and the terrestrial sphere, or right ascension declination and GPS long lat or a geodetic long lat, which is confirmed by the WGS84. So you have a conceptual ellipsoid used for surveying, map making, everything, right? And then they combine that with the celestial spheroid, and then behold, Ptolemy's two-sphere model makes the globe Earth another conceptual sphere. And because he put that forth back in his first book, Geography, which is like the father of history, not technically the father of cartography. They give that title to Eratosthenes for his goofy circumference inference, right? I don't know why that makes him the father of cartography, but he did get, the circumference of the
you
gradient.
call it a fiat.
So the two-sphere model, dude, tell me maybe if you want to understand maps and cosmography, you must accept the two-sphere model of the terrestrial and celestial sphere. So people get convinced they live on a globe because they combine the celestial and the and the terrestrial. So they made up a globe model based on math and a coordinate system and ellipsoidal assumptions, and then that's where everyone thinks that very little verification required. Yeah, Tuesday I'm going to go into that, I think, because it's really important as the backbone. Each one deserves its own prez, but I already did those, so now I can talk about them being put together.
And is it like with a flat Earth sort of mapping of the sky or the hemispheres? Is a counter rotation still like an intuitive thing that you would expect to observe?
Well, the way that they mapped it was just hemispherical observation. So everyone sees half the sky, and you have latitude dependent circles in the sky. Right? If the stars precess and they appear to rise and set over your hemisphere of vision, and everyone sees the same hemisphere of vision, sure, you could pretend that you live on a spherical surface and you're observing half the sky. But the alternative would be you're living on an infinite or a very large plane, and you only see so far based on angular resolution limits, light attenuation, atmospheric opacity, all sorts of things. You get the luminosity thing, all sorts of things, right? Then you have the same sort of mapping system where based on alt-az. Alt-az is altitude and azimuth, right? So an elevation angle from the flat horizon, and then you have a direction which you're facing. Everyone makes those observations. They put them together. They notice the latitude dependency. From that, you create the spherical model. So it's really model independent, right? Because it's just based on observations. Sure, they constructed a spherical model based on those observations, but they're just using a hemispherical and spherical coordinate system. Hemispherical is identical to spherical, by the way, except you have a negative z-axis, and a z would be, when it goes below the fundamental plane, theoretically, it's just away from you further than you can see, traveling on a circle of the same circumference. So observationally identical. The whole argument is that the curvature comes from the sky and corrections over long distances. Right? There's no curvature on Earth, but if everything comports to the stars and every planar measurement gets corrected to astronomical latitude, and you deflect the vertical of every geodetic survey, and every WGS84 needs a range measurement equation with a meridian correction comporting to the WGS84, then yeah, of course it'll work, right?
All right, so let's get into like the the who done it, right? Because when we look at the way that the celestial refraction is kind of accounting for helping them account for their globe. Who did this shit? Who would
Dude,
you say
the Royal
authored it?
Society. The Royal Society seized control of the infrastructure of academia so long ago, and as early as like 1700s, with the Board of Longitude, they were making strides for the globe model all over. They were putting in forth empirical systems. They led like the Board of Measurements. They put forth the meter convention. They were trying to conform everything to the sphere, coming up sphere. If you read Gleason's book, "Is the Earth a Globe? Is the Bible from Heaven?" He goes over the historical contemporaries as he's making his flat Earth measurements. He's like, why are these people trying to manufacture curvature from the these crazy globulars with their assumptions? Like the way he talks about it in his really boring book shows you that there was like a radical few even at that time, and that was 1800s. But you can see the evidence of it from I think the Royal Society is like the front facing visible component of the control, which then funds universities and academia, and that's how you get like peer review, right? So who done it? Obviously, we don't really know who. I would assume the same evil controllers who launched COVID and put everyone through psyops and makes our governments fight each other and starts every war for the profit of bankers. But you can call them whatever you will, right?
Like I even heard, and I'm not sure if I interpreted it right, but I feel like I heard Heffron speak about like an accumulated error and like a difference in the making theodolites where the older ones don't have it and some of the newer ones have it, and it seems to even maybe contribute to making the numbers get a little close. I don't know if I interpreted that.
I think that was
Yeah. So
go ahead.
oh, go ahead.
I was going to say a
That
lot of
was
that
a
was early on. There's like an update. I think there's an update coming that might talk about that more, but most of the stuff that you guys have seen about that was stuff very early on when he was trying to make sense of what was going on with like this old total station he had
Yeah,
for his
he
like
mentioned
annealing
that when he
theodolite.
was in here the first time. That's when I heard him say it.
Yeah. That now apparently he has been looking into some of that a little bit more recently. He might have more to say soon, but we don't mean, as far as the specifics, I don't really know much. I just know that the stuff that he talked about before was from that early stage. But in terms of error, though, thanks to that man Jesse, who made a simulator using the basically the widely accepted celestial navigation correction formulas. He was able to make a simulator that very, I mean, pretty much spot on as far as we've been able to see so far with the 6 or 7 data points we have. Matches what Mike measured in real life. And Jesse's contention was that, well, I'm able to model it. Why am I able to model it? That must mean Earth's a globe because the people who use this use a globe Earth model. But upon when you
That's not
actually dig into,
exactly.
So is it
It's not
thanks
well, he was
Jesse
trying to
exactly
now?
the same.
Jesse got his own hashtag now. Thanks Jesse.
I mean, he was trying to disprove Heffron's method ultimately, but also show that the reason it worked is because it's all derived from a globe. Like, it was a dual purpose, right? And so, I mean, we kind of dug into the literature around it and then into the simulator as well. But what we ended up finding is that this whole celestial refraction thing is not actually like refraction at all. I mean, it is a celestial correction, is what it would more aptly be dubbed. But we have refraction already, which is based upon Snell's law, and it involves things like ratios of pressure and temperature. Pressure is being able to be generally derived from things like altitude above sea level and things like that, and temperature just being a direct measurement. But when you put those things together, you get a refraction coefficient, and that's been pretty well modeled over the past 100 years of empirical science. But that's what you use for objects here, on Earth, and when you look at things through the atmosphere of Earth. When you talk about the stars, there's an entirely separate correction called celestial refraction, and it's actually not just like one formula. Disclaimer: there's like several different ones, and it depends on what the angle of the object you're looking at is. So they'll have like one set of formulas for 90 degrees to like, I think it's like 90 to 75. Don't quote me on it exactly, but something like that. They have another one that's like 30 to 60, like the general midband where it's mostly linear. And then you have another one that's like 15 to 30 or 10 to 30. And then there's one that's like under like 0 to 10. So like the closer to the horizon that you get, the more significant of a like compression, a non-linearity that you observe in the objects as they move towards the horizon. And so every single one of these angle ranges, 0 to 10, 10 to 30, 30 to 60, etc., every single one of them has a different formula. And when you look at the formula, there's actually only one variable in it. The only variable that's taken into account is the apparent angle, which is an angle calculate. Well, I'll just say an angle. We can talk about the angle in a second, but is an angle measurement. There's no temperature, there's no pressure, there's no physical constants in there. It's literally just an angle variable, and then a whole bunch of arbitrary coefficients that are like completely random. Be like 8.341 and 4.056 and 0.0042, like all these different random numbers. Like, where are all these random numbers coming from?
So
Well, the
when they
reason that
say
those are there,
stuff like they used to come in and say oh, it's trivial. It's like is to get like a let's say for Canagoo, all you would need is like I don't know if it's like a 10 centigrade of gradient over like
since these just random numbers are in there, the reason those are there is it turns out the way that they figured this out, it's actually what is known as an empirically derived solution. So there's two types of solutions in science when you're trying to make a formula to fit stuff. Okay, there's a general solution. Now, a general solution would be something like the ideal gas law. It's just a bunch of variables for temperature and pressure and volume, etc. That's a general solution. It's called general because it works all the time, anywhere. It's generalized, showing that you have captured the essence of the physical mechanism at play that's creating the effects. Then there's what's known as an empirical solution. It's called empirical because it's empirically derived. In other words, it's figured out through taking measurements and quantifying those measurements and plotting them in data sets. So an empirical solution is far inferior to a general solution because an empirical solution does not elucidate the actual mechanism by which the effects are occurring, what it's doing is saying there's something happening. We don't know quite how to explain how or why it's happening. All we know is that it is happening, and if we plot enough data, we can plot this data on a curve, and we can compare the deviation between what we expected to happen and what really happened, form fit it, spit out an equation, and we can use that equation to correct any observations we get, and that will be our correction. And that's what they did,
Yeah,
and that's
man. Fuck. I'm
yeah,
so
that
glad you like I just heard you articulate that because like to me, I'm just trying to visualize it. It's like, man, how like in what intervals would you even take the measurements like vertically and then even like forward? Let's say between me and whatever Pikes Peak, like to get the first, let's say to get the terrestrial refraction. Like a fucking
yeah.
cross breeze could probably create a wild swing, and that's like I don't know, man, a
Well,
fart.
the
Like I didn't
terrestrial is pretty
understand.
the terrestrial is pretty consistent because what you do is you just average it out, and there might be some minor deviations on one end or the other, but like it's going to be fairly close in terms of what you're supposed to get on the regular like Snell's law on the Snell's law side, right? But or anything to do with just atmospheric effects. But when you talk about celestial refraction, what the one I just explained, it it is not from first principles. It's not from saying, okay, we're going to use the principles of these dynamics or those effects or these effects. You have none of that. All you have is let's go outside and capture a million data points, as many as we possibly can, and plot them all in Excel. And when we do that, Excel is going to plot a curve for us, and we're going to compare the curve of what we measured to the curve of what we predicted. And there's going to be a difference between those two curves, and we're going to quantify that difference and turn it into a formula. And that
Right,
is
but
our
what's
empirical
what's
solution.
what's the need for that? Are they accounting for what, like the that
Okay, yes.
deviation between the spatial field and the visual field, or is it just
It's
perspective alone that they're kind of trying to come to?
well, are you asking me what they like?
What's the need
What,
for
what
have needing that fudge factor with the with
yeah,
this
it's
thing?
okay. So it's a two-step answer. Step part one, it's needed because the geometry of the drop over distance of the globe makes a certain geometrical prediction. It's not correct. So then you add refraction onto that, and it's still wildly off and still not correct. So they're like, we need some other source of a correction in order to make up this deviation from what we predicted, even with refraction included, and what we actually got. So that's where celestial refraction comes in. Now, what is actually causing it? That's a separate question. That's a good thing to talk about. We could probably do that now. But just to be clear, this deviation also occurs on the FE side. It's just to a much smaller degree. Now, it is true. Jesse did also make a contention that in this, if you were to use a simulator, for example, there are data points where you can find where there's a slightly closer prediction made by the globe geometry than the flat geometry. That is true in a small number of cases, but it's only within a very small range of mountain positions and distances and heights and stuff. And the vast majority of them are FE. And as soon as you get past that distance, actually, because it's a pretty close distance you have to go to, every distance past that, the error just gets bigger and bigger and bigger, and FE and globe get way further apart, and it's always closer to FE after that, more and more and more the further away you get. And
All right,
so,
so all right, go on.
yeah, go ahead.
Nah, I was just gonna ask. So, from people who've kind of been combing through the data set, how trivial, now that you got a picture of it in your, you know, kind of view of it. Pardon me, I'm kind of multitasking. But how trivial is refraction, right? Celestial refraction. How,
Ooh,
because you're ignoring, because the flat Earth is kind of getting the right predictions, like putting it on the shelf and just kind of ignoring it for now. So how trivial is it? And like,
it's not trivial. So to be clear, that celestial refraction correction is going to have to make up for the difference between the timing, right? Because the way the celestial theodolite works is it's all the only measurement we take is a timing measurement, right? Everything else is just computed. The physical measurement we take is not an angle measurement, it's a timing measurement, and the angle is derived from the timing. So in terms of time, on some of the mountains, like the closer ones, you might get a time delta of between the prediction and the actual measurement for the globe of like, I don't know, 4 seconds, 6 seconds, something like that, 4 to 8 seconds, 2 to 8 seconds if it's super close on the 2, more medium on the 8. But then as you get further and further away, like that time delta becomes bigger and bigger and bigger. And so usually we're able to get within a couple seconds on the FE measurements, sometimes almost dead on, but usually within a couple seconds, and it might get a little worse as you go out. But the globe starts getting wildly far off on the timing deltas.
And this is like
And
using the same peak but from different distances.
I mean, you can do the same peak or different distances. Usually, the way it's done is they just pick a different peak because Mike doesn't want to drive all over the country. He'll pick a peak that's like, you know, 30 miles from his house, a peak that's 50, a peak that's 20, 15, etc. Um, but yeah, man, I mean, like it's very clear that there's a compression effect going on. Now, to answer your question that I said was a good one that we could touch on now, what's the actual need for this effect? Yeah, I would say that we live in Euclidean space, but we view a visual field that's non-Euclidean. Now, parts of it operate Euclidean. They operate linearly near the middle range, usually around that 30 to 60 to 70 or so degree range. But once you get below 30, it'll start to compress a little bit. And once you get below 20, it'll really start to compress. And then below 10, it's like it kind of starts to just really just like the horizon starts to squeeze everything a lot. It's an exponential increase the closer you get to the horizon. And so that deviation is actually what is creating, in my opinion, I mean, I'm just guessing, I don't know, I'm not God, but is what's creating the deviation between what we predict with plane trig and what we see by using true positions and eliminating refraction. Because once we eliminate refraction, we use quote unquote true positions. There's still usually a little bit of a deviation. Like I said, it's not usually balls on dead accurate for the further away ones. Some of the closer ones are, but a lot of the further away ones are a little off. But I think that that's accounted for probably by the fact that we know that there is optical compression happening, and it's even accounted for in the formulas that Jesse used in a simulator. All that comes from, right? That all comes from celestial navigation. And Alan pointed this out in his last debate. A big implication of that, right? It's like these formulas aren't pertaining to a simulator; they're actually pertaining to cell nav, like celestial navigation, and the angle that is being fed into these corrections. Like when you do cell nav, you just take your sextant or whatever instrument you're using, and relative to your local horizontal, you plot an angle to a star, and you take the angle that you got and you plug it into the celestial refraction correction formula, and you spit out an effective angle, and that's the one that you use to navigate. But the angle you feed in is always a plane trig angle. It's a flat Earth angle, because you're just comparing your local horizontal to the star. So you're making a triangle. It's plane trig. You don't take your angle and then do a drop over distance correction to the angle and then feed that into the correction. That's not how you do it, because actually,
That's what's so profound about the whole shit. It's just like the raw trig is working. What do you do with
right?
that? What do you say to that?
Yeah, that's how you use it. I mean, I'm sure you could try to figure out a way to eliminate the plane trig by just doing everything from a globe perspective and then doing small corrections to that to account for that difference. But if you just go in the front end using just regular angle measurements, which is what celestial navigation does, that's how the celestial refraction formula is made correct. And if you switch it to a globe angle, it'll actually be off by a little bit. And the further out you go, the more off it'll be. Once again, it has the same problem. So you actually have to use a flat baseline angle in the way that the celestial navigation is performed for it to be accurate to the way it's intended.
Right. So you mean when they do the coordinate system with like the 60 whatever degrees per miles per degree, that's the way they do it, right?
Yeah, the 69 miles per degree. That's what's touted as a standardized drop over distance everywhere on Earth. Um, you know, that could be debated as well. There could be a whole separate debate on that topic. That is generally correct at the equator. That's generally correct at the equator, 69 miles per degree. As far as other places, there are, Shane has some presentations and stuff about that. That's more his wheelhouse than mine. I don't want to speak to it too much. But
Can I say something quick? It
You
is
got
true that anywhere on the world in Stellarium, if you move the observer point in Stellarium closer to the star, straight towards the star, that the star's zenith angle or altitude angle does rise at the rate of about very close to 1 degree per 60 nautical miles.
That's fine, man. I don't need to. Yeah, I mean, that is how the apparent behavior works, is as far as we know.
But doesn't that mean that the angle given by the true geometric elevation angle given by Stellarium when placed on the mountain peak is not the true geometric elevation angle at the observer's location for the star at that moment in time?
Well, the point of the celestial theodolite experiment is to determine whether the effect of that rise or drop over distance standardization is a true geometric physical change or an apparent effect. And the way that that's done is obviously through Heffron's methodology is by comparing the models and by eliminating refraction and using the obvious logic that only a physical object will block a light beam, not a apparent or refracted object, and using the mountain as the physical marker. And then, of course, everything we've just said so far of corrections and all that falls into place after that. But the conclusion of Heffron's methodology is that the effect of rise or drop over distance to a standardization of, 69 miles per degree or whatever you want to use, that is ultimately apparent in nature, because if it wasn't, you wouldn't be able to have the occlusion work the way that it does.
So you're saying that for, let's say there was suddenly no air on Earth, but everyone could still, they had oxygen tanks on. Two people, one closer to the same star, they would actually see it at the same time at different elevation angles just because they were in different locations?
I'm not making any claims about. I mean, taking the air away would only affect local standard refraction. It wouldn't change the fact of the geometry involved.
Right, but one of the cornerstones of this method is the claim that Stellarium always gives the true geometric direction elevation angle to a star if atmosphere is turned off, right?
Well, the point is, right, like the point is that when you go to the mountain, it's going to give you an angle. Now, in reality, whether that's truly a true physical angle to the true physical star does not matter, because the comparison that's being made is whatever the angle it gives you at the mountain location, it has to be a different one at Mike's house. So that means that there's no possible way to trace a line to Mike's house that's continuous from his house to the mountain to the star if it's a physical effect, right?
I was trying to
It,
tell y'all. I was trying to tell him. I swear to God, I was trying to tell him.
so it would have to, in order for that to happen, whatever's happening in the sky must therefore necessarily be an apparent effect, because otherwise, as I said, you wouldn't be able to use a planar relationship to represent the occlusion.
Oh, by the way, you mentioned that the simulator showed that there were locations that would match globe. I actually went out and to two different locations. One which gave, and I actually filmed star occlusion timings. It's on my YouTube, and one of them matched globe perfectly, spot on, and then the other one gave tiny Earth results using Dr. Heffron's method. The beauty of this is that he has come out with a little correction that lifts up all the angles a little bit. That lifts my first one up so it no longer matches globe, it's closer to flat Earth, but it lifts also up my second one that was too low for globe and brings it within about 2 arc minutes of globe. So even with the correction, now there's still one that matches the globe.
Yeah, I mean, I fully acknowledge that within a simulator that starts out, with some angles being below the glob prediction, some being above the glob prediction, there's going to be a place in between there where you have to cross that line. That's like the law of numbers at work right there. So it's fine that happens, but what's not fine is that, as soon as you get past that point, every single observation beyond that distance just builds up a growing and increasing error that causes the globe to deviate further and further and further, and it's never closer than FE ever any point past that. And
Well,
so,
and as you get closer to a mountain, it gets farther and farther and farther towards tiny globes. So, and farther and farther from flat Earth. So it's the same problem going the other way. The closer you get, the more towards globe, and then smaller and smaller radius you get. And the farther you get, you go first to flat and then to concave, and the farther you go, the further you go towards concave, right?
No, you're assuming that the deviation is caused by changing the Earth's size. No one's doing that. We are acknowledging that there is an actual optical compression effect. You have to say that it's refraction, even though it's not refraction. It's an arbitrary ad hoc correction made using empirical data sets that were form-fitted to the disparity between prediction and measurement, and just attaching the label of refraction to it. We just say the way we see is non-Euclidean, and therefore when we get close to the horizon, that compression is going to add up and create a slight deviation from plane trig. And it's closer to our numbers than yours.
The point is, my observation was at about like 24, 25 miles, and my elevation angle to the mountain was, around a degree, I think it was, very similar to many of Dr. Heffron's readings. And in every way, my data, my real live recording of stars coming out from behind that mountain, meet all the requirements that set forth for a valid celestial theodolite reading, and yet they match the globe perfectly. So that,
Jesse, are you talking past everything I'm saying, bro? Like you did this
Purposely,
same thing,
dude. I don't know why you engaged him at all, to be honest. But
it's
whatever.
fine. It's fine. I gave him a chance. You have to act in good faith one time, right, Shane? After one,
Okay,
once,
okay.
shame
But
on
how
you,
many times
fine.
have we done it? Is 700 too much, or
It's
how many
okay.
times?
But yeah, so anyways, I think we summarized it all. Like I acknowledged that there's a simulator and there's numbers in there, and he's kind of just trying to repeat and go in a circle and go on and on and on. I mean, it's like unnecessary in terms of time efficiency at this point. But thank you for your
it's more than
contribution, Jesse.
it's more than a simulator. There's real world. I literally went out in the real world and really filmed stars in the real world and got globe results matching using the Heffron
Are
method.
you saying anything different from what I've already told the entire audience so far?
You kept calling it a simulator. I just wanted everyone to know it was not a simulation. It was a real thing.
Why do you have such difficulty with yes or no questions?
Extremely pedantic
No.
on purpose, but it's okay.
Well, yeah, it's just like John,
we're aware.
right?
Yeah, we're aware. It's okay. As if as if there's like a semantic argument that can be made, which will change the outcome of the reality behind everything, or something.
As long as they can get other people to think that from what they say, I think that's acceptable.
Right, like if you take up enough of people's time, maybe it'll seem as if there's something to what you're saying, because we're not
That's
necessarily all technical enough to get it. But since they're arguing so much, maybe it's not so clear. That's the impression that goes over onto people when they're not technically proficient enough for themselves to always understand it to a granular level. But the reality is, it was already explained. It was, talked about it. I was very faithful as best as I possibly could to give Jesse a fair shake of what the simulator did do and what it did do correctly. And obviously the simulator is based on, once again, it matches, I said very explicitly, it matches what Dr. Heffron measured. So there's no trying to undercut any other measurement. If you take a measurement and matches yours too, that's to be expected. The reason it matches, as I stated, was it uses celestial navigation corrections, which are based on empirical data sets and form-fitted to quantify the disparity between prediction and measurement in the real world. That is how it works. It doesn't work without that.
So what's causing this method that is immune from refraction to sometimes give globe results and sometimes flat results?
I have already explained it twice now.
You're not listening to yourself.
The recording and listen to it again.
It's funny because he thinks it's a gotcha, but it's actually just showing ineptitude. Jesse, it comes off as inept, It comes off as you not understanding what they're
Well,
saying.
only to us. To the peers and the Globers, it comes off as first glance plausibility and adequate, right? That's what McTune's whole goal is. That's what the whole point is. That's definitely what John's goal is by eliciting emotional responses, by intentionally instigating and speaking slowly. And, those words smarmy and unctuous come back to mind again. If I can pretend to be sincere enough so that other people get the impression of a coherent refutation, then my job is done. Or in McTune's case, just smile at the camera like everything's cool and smirk till the end.
Right,
Yeah,
and filibuster is a valid argumental technique. I mean, if you waste a ton of people's time, it seems like you're doing well, but you're not.
No timing
You don't
Jesse,
actually
then.
have any point. You have no valid
Well-
justification or belief. You have no claim. You just ask annoying questions and waste time. That's you,
No,
Jesse.
be nice, guys. I'm one of the very few people, probably the only one on the globe side, who's actually gone out and gotten real star occlusion timings. I'm really trying to figure this out. Okay, so don't be
Right, let's-
quite so hard.
No. Okay, I'm gonna ask you one more question, and then I don't really want to engage in this topic anymore with directly with you, because I mean we plenty of people in here got questions, but I do want to see if here's your chance at honesty. Here's your chance before everyone to demonstrate that good faith you claim you have. Is it or is it not true that in order to correctly be able to use celestial navigation and or a simulation of it, which you have built, but in order to correctly use celestial navigation, one has to perform a correction for what is called celestial refraction, and that utilizes an empirically, not a general solution, but an empirically derived solution for the disparity between geometric prediction and real life measurement.
Is that
Yes
true
no?
or
Is
not
that
true, Jesse?
Is that true or not true?
I don't know. I was not involved in the derivation of the formula for correcting for astronomic refraction. Am I allowed to not know something?
I mean, that's fine. But
Well,
now
if
that
we're-
you've admitted that you don't know, we know because we researched it to verify it, to figure it out. So now that means that you're just using a formula that you found in a book somewhere. You don't know why it works. All you know is I plugged it in and it works. And we're explaining to you the reason why it works and how it works and what is being done within that formula. And then all you're doing is kind of just ignoring everything we said and being like, well, but guys, I made a formula and it works. Why is it that there's places where the globe works? As if we didn't just explain it and you heard nothing we said.
Well, the key point here is that the original claim of the Heffron method was that it was eliminating refraction and that it was reporting the results of the physical arctangent of the rise over the run of the mountains.
Jesse, I do
Unfortunately,
not believe that you
this-
did not hear what they had just said. I do not believe that you did not hear what Piezo just said.
Could I
do
finish
not
my
believe
sentence?
you.
I was getting there.
He doesn't care what he
I
said.
do not believe you when you say
I
you
mean,
didn't
literally
understand
makes no
what he had
difference.
just said.
Yeah, I mean, so for everyone watching, if you saw the way he kind of just talked through it and circled back and just started to repeat the same point he's made 4 times already, when offered an opportunity to continue in good faith and honesty claims that he's operating in, and then just didn't do that. This is the everyday natural behavior every time anyone interacts with him.
It sucks. I deal with John with it all the time. Do the same thing.
Now, hold on.
Yep, all three of them.
I honestly
Jesse,
answered the
nobody
question.
believes that you didn't understand what was just said to you. No one believes you.
You didn't
You've
let me
lost
finish my sentence.
credibility.
I was
Yeah, no one
responding
believes
to it.
you.
Well, okay, gentlemen. Obviously, you're just going to continue to cut me off. Thank you. Have a wonderful day.
Also plays the victim card every time as well, and it tries to have this online persona of this poor little guy who everyone's mean to, and is just trying to get real answers to real questions, but no one seems to have them. Oh, egad, what's going on? Why does everyone mistreat me?
Yeah, you got me with that.
Yeah, in reality, this is what he does every time.
Dude, I remember I had to learn in 6 months. Yep. Dude, smarmy and unctuous, right? I'm going to pretend to be so sincere. It describes him to a T. I'm going to be ostensibly going to be interested in the results, and I'm going to just want to help prove, and I have no goal. And that's him, dude. Completely insincerely, whatever.
Hey, we've made progress.
Let's go
though.
over
now
it.
We have an admission. Yeah. We have an admission from Jesse
that he doesn't know why
he's
using those correction formulas. Exactly.
Yeah, he doesn't know where they came from.
Which is
science.
Worse.
Yeah. Well, we found out. So thanks for him for forcing them in to present his quote model that answered us.
listen, in his defense, like he said, he's the only globularist participating. So,
Well,
gotta
So if
be
someone said
cordial as
that, like
possible.
to
I
answer,
know.
oh my bad.
But
Yeah.
you're good. Anyway, just trying to remain cordial, lads.
Oh, I didn't
That's all
insult him.
good.
I mean, I just said this is his
I
typical
know.
behavior.
I'm not talking about that.
So if someone would like to speak up for Jesse and say, well, those, it was derived from science. What would you? What would the response to that be?
I mean, technically that's
So,
not wrong, but that's not specific enough to mean anything.
yeah, so I have the exact breakdowns and papers and references that all of it is derived from. And then, so like basically when you walk through like even in the papers, they say like, uh, this isn't derived from any laboratory experiment, and we would like to do more laboratory experiments to try and prove what we're calculating is true. But regardless, here's the calculation, which is just as described. It comes from an expansion series, assuming the globe is the input, and then wouldn't you know it, the output is the globe, and all it's doing is explaining why. It's trying to explain enough refraction to which gives them the mechanism to say like why the star is still visible when it should be following that 15 degree per hour relationship that John was talking about earlier. And then like whereas we're asserting like there's refraction, right, but there's also optical compression and it's non-linear. So the reason why it's still there is a mixture of refraction and optical effects, not ground curvature effects. But the coefficient, the what it does, right, it just keeps it coplanar with the ground.
Coplanar with the ground. Actually, oh, there's the other
Isn't that
thing.
an
I
old
almost
country
forgot.
song?
I almost forgot, Alan.
Coplanar.
Before you guys leave, don't forget. Um, man, we need to do that. Well, maybe it'll come soon. Maybe it'll come soon. I'll just leave it at this. I'll say maybe we need to do this, and maybe it'll come soon. But in the very beginning, when Mike did the first set of mountains, remember he just randomly was like, you know what? I wonder what'll happen if I apply the celestial refraction formula instead of putting it to the star. I put it to the mountain. What will happen? And sure enough, that apparent globe mountain angle got turned into a plane trig flat Earth mountain angle. What a coincidence! Even Ruhif was in our chat, like saying, "Yep, that's just a coincidence." Remember, it was like 3 months ago.
I do remember that.
Yo,
Yep.
if you guys have any more questions, I'm gonna dip out in about 10 minutes. So you gotta get dinner going.
Okay, can I get a quick, short summary of the update? I'm sorry, I'm just tapping in before you head out. Sorry if it's too
Lord,
much
killer
talking.
fashion just
flat
coming
Earth.
in out
I
of
know I
Yeah,
crashed the party late
I got you,
towards the
dude.
end of the party.
Flat Earth
Yeah, yeah.
wins. Globe has no timing still in the end.
You have
Okay,
no
okay.
predictions. You have close
No,
time
no, no. What?
rebuttals.
No, let him ask his quick question. 10 minutes. Come on. What you
Well,
got?
his
No,
question was to recap the whole thing. What do you mean?
yeah, quick recap. Yeah,
Oh, that
yeah.
was his.
That's all.
Oh,
Yeah, that was it.
I mean that's why this is recorded, right?
You have to
Yeah,
catch it
I was
real
gonna listen
quick.
to it, but yeah, I'm about to do something now, so now I
Double
gotta go.
refraction is the only answer. It's the only thing they can come up with is double
Okay,
refraction.
there's still double refracting. We refract to the mountain, and then from the mountain peak to the star, then we refract it again. That's what they're doing, right? Basically.
Yeah, yeah. I mean, the celestial refraction is just going to make up the deviation between what we observe and the globe baseline. That's what it's
Understood.
for. Yeah, and that's why when you take the apparent angle to a mountain peak and you take the angle that you got and you plug it into the celestial refraction formula, it spits out the plane trig angle. Weird, right? I mean, like why would a formula built for the stars that doesn't have any, temperature, pressure, or terrestrial variables in it at all, why, when we just plug in the apparent angle to this mountain, does it turn it into a flat angle? Like that doesn't, those two things have no correlation to each other. So why would it work that way? Why would that happen? Unless, right, what the celestial refraction formula actually is an empirically derived formula that actually accounts for the deviation between a globe profile and a flat profile. So when you plug in an angle into it, it's able to transform it into what the other baseline is. You see, that's what they were doing, is they were quantifying, as I said before, the deviation between the globe expectation and the real world measurement.
But we did that for 3 hours. It was that, but for 3 hours, essentially.
Yeah.
Okay, no, I'm gonna check. No, I appreciate that. I'm definitely gonna listen to the replay for sure.
Well, honestly, we would say that about 30 times, and they would come back with different forms of butt refraction. And that's kind of been the whole thing, the dance ever since. So really not more of the same and nothing new. They're getting creative, though. John created some visual aids where he could present his non-related arguments on visual optical angles and then, try to muddy the water. And then Jesse did his thing with the calculator where he just enforced in some celestial corrections that we had to look into to figure out where the constants come from to identify best fit curve lines on linear measurements all over. So yeah, it is what it is.
So here's my question: are they able to predict when? Have they been able to like accurately predict, like knowing the variable for refraction ahead of time? Like, hey, no, I'm assuming, you guys would be able to do that like tomorrow, 2 months from now, and still get the same answer. Are they able to have they shown that they're at least able to predict the refraction variable, like, and get the correct answer? Has at least that been demonstrated, or has all
You're
been
not.
like post hoc?
It's not a refraction variable. We're not predicting a refraction variable, right? You just predict the geometric angle, and then you go take a measurement, and there's going to be a deviation. That deviation just so happens to always be fixed by the celestial refraction formula, and that's what the celestial refraction formula is. It's not actually
Okay,
refraction.
okay. It's bit
We
like
call it
pretty much
celestial
standard.
correction.
It's like a standard number.
Can
It's not a number. It's a formula,
you
right?
predict
Okay,
with a
I guess I'm gonna
correction?
have to look up more into it. Okay, I'm gonna listen to the replay. I'm gonna listen to the replay.
Yeah.
Can you
All right.
predict with
It's
a
empirically
correction?
derived.
I heard someone call it math fraction the other day. I like that.
Now your best one was refraction Jackson. They just go refraction Jackson on it.
Dude, it's the best
Yeah, we
answer
used to
for
have a theme
everything,
song.
but they can never use it to predict anything. It's the magical fix. What observation did you make? Well, let me figure out what refraction coefficient I need to plug into my R radius formula to make sure that didn't happen, and we're fine. And that's been the argument ever since this, right? Which is why we tried to bring in something absent refraction. And we all predicted that all they would do was try to bring refraction back in because, just like with Battle of the Beams, there really is no other way to explain any of this real world observations.
Well, refraction doesn't even begin to save Battle of the Beams. They're just cooked any way you look at it on that one, brother.
Nope, but dude, that's what they presented twice, and then the drunk boys vaguely confirmed it
Dude,
by making no points.
it's
So
even
that's
worse
the
'cause
stance.
they present it with no math. They're just like, it's just refraction and diffraction and
Just loosely implied it. It was the weirdest argument ever in the presentation, full on detail. It just vaguely implies something and move on.
Dude, what's funny, bro, and what's really ironic is that in order to be able to argue our positions on some of these things, such as Battle of the Beams, we have to go into graduate level research in order to find all this data and information from the past, dig up the history books, do the math ourselves, look up the technology, get the freaking physical geometry of the antenna, and like all this different stuff, right? In order to be able to even understand what's happening. And then we find the papers from the manufacturers, the tests, the quantification of the effectiveness.
And then construct an argument with it critically, and then refine the argument live time as we go, right?
And then make like a 1 hour presentation on it to condense all that information into a digestible format and deliver it to these people. And then they think that like a 1-word answer, refraction, is like a sufficient rebuttal. It's just so laughable, dude.
We focused on things that refraction has a minimal, like the Battle of the Beams is so least affected by refraction. It's the best thing. Like if it refracts, it has to reconnect. The actual whatever, the middle beam or whatever doesn't recombine. The signal doesn't go. You don't get the beeps. The whole thing wouldn't work. That's why both of these are really excellent arguments. And of course, the Battle of the Beams, they just kind of vaguely implied and then stopped talking about it. But now with the celestial theodolite, they're just like, oh look, 26 types of refraction. You guys ready?
I mean, you've got diffraction, refraction, and skywave propagation as your only three possible attempted options to explain it, and all of them completely fail.
Right. We thought
For
about
reasons.
that. We knew the answers to the thing we were putting forth, and we researched it. So it's like the thought that you could debunk a 14-hour deep dive with a Google search is kind of insulting.
Well, and that's the thing, dude, is once you acquire the level of technical information and knowledge of the subject matter that's being discussed, like, you know, beyond any shadow of a doubt that their arguments are stupid. Not saying that in offense to the person, just like the argument itself being presented as stupid. But like, for the people that don't know that, they're listening to this and trying to gauge the, you know, the accuracy and validity of these various viewpoints. To that person, it might seem a little bit more like mundane and not sure which one might be right. Like, they have to really focus. But for you sitting in the driver's seat, knowing all this information, it's so beyond explicitly true to you and so beyond explicitly false what they're bringing forth that, like, it's laughable sitting in your shoes that they're even saying these things and claiming that it's a valid argument. Like, it's funny, but you have to hold it down for everybody in the audience who doesn't yet know that, and do a good job of presenting this information in such a way that makes it clear that their arguments are bad. So that's the challenge.
Well, can you imagine when they launch a campaign, a character assassination campaign on your like character and your honesty and like the projectile vomit just call you dishonest at every turn when they just make bad arguments. When they can't,
Yeah,
they can't find a way around what you're saying. They just say you're lying and being dishonest.
right, and that's the point I'm making, is like, you're doing this for the benefit of all the other people listening so that they can come to the same understanding that you have, so that they can get it too, they can digest it too, they can think for themselves, evaluate it, and come to the same conclusion to find what's correct. But in the meantime, while you're attempting to accomplish this, you're just in your head hearing these arguments, and it's like, man, this is painful to hear this person present that as like a counterpoint and think that it makes sense. Okay, and then you have to go through it like 3, 4, 5, 6 times in a row with the opponent, and it's still not clicking for them because they just don't want to get it, right? There's like a philosophical barrier, right? There's like this cognitive dissonance wall that you're having to like drill through with like a a hydraulic press of logic, and it's just, some people are just impervious to reason. That's what makes the whole process very painful.
I remember listening to the PhD geophysicist Brazilian dude who's came out and gave his flat Earth testimony. He said the same thing. He's like, when he listens to people, like he took it. He's like, listen, I got PhD in seismology, geophysics, like at the top. I know everything there is to know about geophysics. I took it to the top, level. And when I hear people make geophysical arguments for a globe, like these people have no fucking idea what they're saying. They make really stupid arguments that just aren't true. It's painful to listen to.
Well, that's Jamal. It's funny, man, because like when I first came into this like group, like not that long ago, like it was like a year and a half ago, I want to say, I didn't know hardly much of this stuff, but once I began to understand it, started having conversations and talking with people online. I mean, like CERN physicists, people who are supposed to be like at the leading forefront of modern theories of electrodynamics, things like that. These people can't even answer like, what's a photon, what's a virtual particle,
You're
what's a
telling
field.
me, imagine me and the way I speak, and when I hit them with these, like I've a 3 years of college, you know what I mean, and dude from the Bronx, and like man, have them ripping their hair out and just ask them simple shit like, what's waving, is a wave, is a wave a noun or is it a verb? And what's a photon exactly? Questions like that. Even like, what's a field? Fucking lose their shit.
All right, guys. Well, I think we're about to wrap up. So I think everyone, thanks for tuning in. We had a good time with the Clubhouse lads. Everyone should hang out with Flat Earth Gang. And Alan says Ether Cause merch is on the way soon. Picked it up yesterday.
Well, that was fun, everybody. Thanks for having any
Man, for sure.
questions.
Appreciate you.
Mother, you been lying to me. Trusted your word, your quest. Now I see, though, just like all the rest. Trusted your word, believed your lore. Now I see through, can't trust you no more. Psychologically abused since I was a kid, believing your stories, the things that you did. Now I'm asking for my money back. I have it tallied up, 800,768 fiat dollars. Gave you my trust, followed your way. Now I see the deceit on display. NASA, you've been lying to me. Lies and deceit, it's all I see. NASA, you've been lying to me. But deception's a game you played every day. Lies and deceit, it's all I see. NASA, you've been lying to me with your fake streams and false reality. NASA, you've betrayed my trust with your fake streams. I stopped being blind, admit you're unjust. Lies. Since I was a kid, you fed me lies, stories and fables. Now I realize, meant for the masses, to be force-fed to the blind. NASA! You've been lying to me with your fake streams and false reality. NASA! You've taken my trust through your lies and deceit, turned it to dust. You've taken my trust through your lies and deceit, turned it to dust. Trusted your word, believed your lore. Now I see through, can't trust you no more. Gave you my trust, followed your way. Now I see the deceit on display. NASA, you've been taken from me. Lies and deceit, it's all I see. NASA, you've been taken from me. Believed in your quest. Now I see though, just like all the rest. Believed your lord. Now I see through, can't trust you no more. Lies and deceit, it's all I see.